screen is displayed? Screen display varudha?
Yes, sir.
Hello?
Yes, sir. Varudhu. Sir, இது C22க்கும் உள்ள பேட்ச் தானா?
Combined. A22, C22.
Okay.
A20, BCA. MCA, MSc, IT, BCA combined.
Okay, sir. Okay.
Okay. Let us start. Computer network. First definitions. Computer. What is computer network? Okay. So 30 years back, ஒரு 30 வருஷத்துக்கு முன்னாடி நெட்வொர்க் யூசேஜ் இஸ் வெரி லிமிட்டட், வெரி ரேர். ஓகே, சொல்லுங்க. எஸ், ஒரு 30 years பேக் நெட்வொர்க் யூசேஜ் வந்து வெரி லிமிட்டட். Okay, everyone they use standard computer. So all the work, computer work, it has done in a single computer. There was no data sharing. Okay, how they can share a data? So through the hard disk, floppy disk and hard disk. Through disk, through physical transmission, data is transferred from one system. ஸோ இடையில யாரும் மியூட் பண்ணாதீங்க. சில பேர் டிஸ்டர்பன்ஸ் பண்ற மாதிரி இருக்கு. ஏன் 250 பேருக்கு அட்டென்ட் பண்றாங்க. நான் ஒவ்வொருத்தரையும் பார்க்க முடியாது, வாட்ச் பண்ண முடியாது. மியூட்ல வைங்க, அன்மியூட் போடாதீங்க. என்ன எதை மியூட் பண்ணாதீங்க. அப்புறம் யூஸ் இருக்காது, கிளாஸ் எடுக்கிறது வேஸ்ட் ஆயிடும். ஓகே, ஸ்டார்ட் பண்ணலாமா?
Hello students.
டிஸ்ப்ளே வருதா?
Good morning.
Good morning, sir. Good morning, sir.
ஹலோ, டிஸ்ப்ளே வருது?
Good morning, sir.
Sir, varadu konja screen பெருசா ஆக்கிங்க sir.
அந்த அவங்க அட்மிட் பண்ண வேண்டியதா
Today
இருக்கா?
we can
அதான்
start
ப்ராப்ளம்.
transmission
ஜாயின்
media.
பண்றாங்க இல்லையா?
Okay, okay.
அதனாலதான்.
So there are two types of transmission media: guided transmission media and unguided transmission media. Guided means physical transmission. Unguided means wireless transmission.
உங்கதை அன்மியூட் பண்ணுங்க. யார் இது? 6041.
Characteristics and quality determined by medium and signal. So main difference both
right
wire
computer
and wireless
network,
transmission.
a collection
it
of computing devices
from one place
that
to
are connected
place.
in various
So
ways
difference is
in order to
quality
communicate and share resources.
So
the
for
data
guided,
computer
the
network
medium is more important.
data வந்து
For
easier transfer
unguided,
பண்ணலாம்.
the bandwidth
ஒரு systemல
produced
இருந்து
by the
இன்னொரு
antenna
systemத்துக்கு,
is more important.
connected
So if
devices,
it has higher bandwidth,
collection of
it
computing
transmits
devices.
more number of
Computing
signals.
devices means
In
laptop, desktop,
in physical
and
transmission,
palm top, okay, and mobiles. So these are the computing devices. So which are the devices are connected? Which are the devices and also printer, okay, through Wi-Fi.
Naveen,
we can
don't
connect our printer to the system, and we can take printout. So all the computing devices that are interconnected, that is called a computer network. So in why we have to interconnect? So we can share resources. So printer is available in one system. Okay, if systems are interconnected, so we can share printer, and one system is equipped with hard disk and CD, compact disk, and other resources, scanner. Okay, so one system is equipped with all peripheral devices. ஒரு சிஸ்டத்துல எல்லாமே, but other systemத்துல only computer terminal is also available. Terminal, mouse, and also system tower. So if all the systems are interconnected, we can make use from other system. The resources can be shared. So for that purpose, for sharing of resources, we can interconnect all the system, all the computing devices.
So for guided transmission, the medium is more important. In which medium?
The connections between computers,
there are different types of physical medium
made using physical wires.
It should transmit at the fastest rate.
Connections எப்படி நம்ம provide பண்ண முடியும்?
There is a
through cable,
benefit
through cable only we can make a connection from one system to another system.
The bandwidth
so that
produced by the antenna
may be
is
wire
important.
or maybe wireless.
Or data
so wireless
rate
and
distance.
How much
distance
some connections are wireless.
Transmitted data.
Okay, wired connection.
So what is the
wireless
data rate? So these are the key concerns
that is
in the transmission.
definition. A collection of computing devices that are connected in various ways.
Okay, so there are two types of transmission media.
Another
guided and
so the generic term
guided means physical transmission,
refer to
and unguided means
network.
wireless.
If any system is connected to the network or internet, we say that is called a node or host.
Next,
a data
design
transfer
factor.
rate,
Bandwidth
the speed
higher
with
bandwidth
data is moved
data
from
rate.
one place on network
more
to
number
another.
of signals can be
with
transmitted.
which data
transmission
is moved from one place. ஒரு place ல இருந்து இன்னொரு
loss of signal
transfer பண்ணுவோம்.
during
speed தான் என்ன சொல்றோம்? Data
heat energy.
We can transfer data or we can move
corrupted.
data from one system
so
to another
attenuation
system.
means loss of energy.
On a single network, that is called a data transfer
voice
rate.
interference.
Data transfer rate
electrical
is a key issue
interference.
in computer
due to
network.
interference,
So transfer
signal
rate
may be
will
lost.
it should be must
and
fast.
due to heat energy,
per second,
due to
1
electrical
GB,
interference,
1
due to
gigabit data, and
voice
1 terabit of data,
may
it
be
can be
lost
transferred
or
from one
corrupted.
system to
number of
another
receivers.
system.
In guided media, more receivers introduce more attenuations. Okay, so in guided media, so number of receiver also it is one of the factors.
Next. Computer networks have opened up an entire frontier in the world of computing called the client-server model. So there are different in a network. There are different server model. Okay, so there are different models.
Next.
OSI model, client
more
server
receivers
model,
introduce more attention.
TCP/IP
So
models.
design factors.
So
These
the
are the
computer networks
factors.
have
Bandwidth,
opened up an entire
transmission
frontier
impairment,
in the world of
interference,
computing
and a
called
number of
the
receivers.
client-server model. Request and a client can make request the server. The server it can process the client request. After processing, it's respond to the client. It send output or process the
Electromagnetic
data.
spectrum.
The client
So these
it
are
can make a
due to
request.
there are different
The server
magnetic
it can
spectrum.
process the
Frequency
client
heads,
request. That is
10
called
power
a
2, 10
client
power 3,
server
10 power 4, 10 power 5. So
model.
power from 10 power 0 to 10 power 4 at ELF. That is a low frequency. Extremely low frequency. ELF means extremely low frequency. VF means voice frequency. So from 10 power 0 to 10 power 2, extremely low frequency. Up to
There
10
are
power 3,
different servers.
very voice frequency. Up to 10 power 4, there is a
file server, web server. What is mean by file server?
very
a computer
low
that stores
frequencies.
and
So
manages
up to this
files
frequency,
for
power and
multiple
telephone,
users
rotating
on a network.
generator,
So
musical instrument,
the
voice
file server is
microphones,
also a
these
computer
devices can
which
be
stores and
used.
manages file
Okay,
for
so
multiple users
that is
on
the
a network. So the
electromagnetic
all the data
spectrum.
it will be
From
stored
10
in
power
file
4
server
to 10
only.
power
Where which
9,
are the user
radio
can
and
request
television,
data.
electronic
That
tube,
request is
integrated
considered
circuit,
or
cellular
processed by
telephony.
a server
They can
and
transmit a
send
signal
a
from
data or file to
at
the
10 power
client.
4
So that
to
is
10
a
power 9.
file server.
Low
It
frequency,
is also
medium
a
frequency,
computer.
MF, medium
Next,
frequency,
web
high
server.
HF, high
A computer
frequency,
dedicated to
VHF, very
responding
high
to requests
frequency,
from the browser client or
UHF,
web pages.
ultra high
So web
frequency.
browser, web server means so a
Each
client computer is called
wireless
client.
device, it
So that
can
is a
transmit
through
at
browser
particular
we can
frequency.
send
It can transmit
a
signal
data
from one place
to
to
the
another place
server.
at the
So the
particular
server
signal.
it
So
is available
from 10
somewhere
power
in
0
the
to 10 power
world.
4,
அது எங்க
at
வேணாலும் இருக்கலாம்
normal
web server. Okay, it is
transmission can
processed
be
by
used.
it is in a
Telephone,
web server.
power cable,
Okay,
a
after
generator,
processing it sent to
instrument,
the
voice
client.
microphone.
So in
They
web
can
server
use
model
up to
we
10
need
power 4.
browser.
Very low
Here
frequency.
browser is acting as a
From
client.
10 power 4
Through
to 10
browser
power 9,
we can communicate
radio
with
transmission,
the web browser.
microwave
So basically
transmissions,
there are two type of
electric
server,
tube, cellular
file server
transmission
and web
are
server.
allowed. From 10 power 9 to 10 power 11, microwave, radar, microwave antenna, magnetars. Okay, 10 power 11 to 10 power 14, infrared, laser, guided missile, range finder. Each the communication device
Local area
it
network.
transmit at the particular frequency only. At 10 power 15, visible light, that is optical fiber. So from 10 power 0 to 10 power 8, we can
A
use
network
twisted pair
that connects
coaxial
a
cable.
relatively
From 10 power
small
3 to
number
10
of
power
machines in a
9,
relatively
coaxial cable
close
is
geographical
used. And
area.
10 power 6
So that
to
is
10
called
power
a
7, AM radio broadcasting device can
local
be used.
area
From 10
network.
power 8 to 10 power 9, FM radio and television device can be used to transmit a signal. From 10 power 9 to 10 power 11, terrestrial and satellite transmission can be used. Okay, so these are the wavelength in space meter. Here 10 power 2, 10 power 3 means frequency. And here wavelength 10 power 6, 10 power 5, 10 power 4, at particular wavelength data it can be transmitted. So there are three types of transmission media: twisted pair, coaxial cable, fiber optic cables. These guided means physical transmission, wired transmissions. There are three types of transmission: twisted pair, coaxial cable, and fiber optic cables. That is a characteristics of guided media: frequency range, typical attenuation, typical delay, and repeater spacing. Twisted pair with loading 0 to 3.5 kilohertz. It transmits signal up to 3.5 kilohertz frequency range. Attenuation 0.2 decibel per kilometer at 1 kilohertz, and a typical delay 50 micron seconds per kilometer, and repeater spacing 2 kilometer. At every 2 kilometer, a repeater is required. For twisted pair with loading, twisted pair multi-pair cables 0 to 1 megahertz, 0.7 decibel per kilometer at 1 kilohertz.
So you see the definition.
Delay 5 microseconds
A computer
per
network
kilometer.
often simply
Repeater,
referred
2
to
kilometer.
as a
So twisted pair for multiple pair cable is
referred to as a network
recommended.
is a collection of computers
transmit
and
a
devices
signal.
interconnected by
Coaxial
communication
cable.
channel that
Frequency
facilitate
range
communication
0 to
among users and allow
500
user to
megahertz.
share resources.
Up to this frequency range,
Next
data
thing.
it can be transmitted. Typical attenuation 7 decibel per kilometer at 10 megahertz.
Local area, that is
Typical
types of
delay
network.
4 microseconds
Local
per
area
kilometer.
network.
1 to 9 kilometer repeater spacing. Every 1 to 9 kilometer there is a repeater to regenerate a signal.
There are three types
by
of
optical
network:
fiber or fiber
LAN,
optical cable.
local area
Frequency
network,
range
metropolitan
186
area
to
network,
370
and
terahertz.
wide area network.
Transmit a signal.
Okay, so there are
Typical
three
attenuation.
types. So in which the types of depending on volume of usage, depending on geographical area, we use concerned network. So here a LAN connects network devices.
So optical fiber 186 to 370 terahertz,
A
0.2
LAN
to
connects
0.5
network
decibel
devices
per
over
kilometer, 5
relatively
microsecond per kilometer,
Yeah,
40
okay.
kilometer.
A relatively
Repeater
short
spacing
distance,
required
a
at
networked
every 40
office,
kilometer.
building,
So that is
school, or
optical
home
fibers.
usually
Transmission
contains a
so that is the
single LAN.
characteristics.
Through
So these
sometimes one
characteristics
building
range from
will
different
contain
three
a few
types:
small
frequency
LANs,
range,
perhaps
typical
one per
attenuation,
room, and
typical
occasionally
delay,
a LAN
repeater
will span
spacing.
a group of nearby buildings.
First,
In
twisted
addition
pair.
to operating
So it's
in a limited
separately
space,
insulated.
LANs
So
are
twist
also
per
typically
every
moved,
1 meter.
controlled,
Per
and
every 1
managed
meter.
by
So
a
it is
single person or organization. So the local
cable,
area network,
twisted
it
pair
is
cable, it
managed
will be
by
twisted.
single
So
person
to
or
avoid the
an
interference,
organization,
so the cable
or
it will be
company.
twisted.
So the local area
Separately
network,
insulated.
it has
So insulated
a
means
short
it has two copper
in the
wire.
distance
Twisted
up
pair
to
cable,
2.5
it has
kilometers,
two copper
it will
cable.
work. So
Two
we
copper
can
cable
use
is
local area
insulated with
network
plastic
in
thin
school,
material,
college, and
twisted
offices,
together, often bundled into
other
cables. So
commercial
they are
areas,
bundled
commercial buildings.
into cables.
We can use local area
Usually
network.
installed
So
in building
in
during
local area network,
constructions.
all the computers
In
are
early days,
connected through
telecommunication
cables.
department they use
twisted
Next,
pair cable.
metropolitan area
through
network.
twisted pair cable,
So,
telephones
a
are
MAN
connected.
is a larger
Telephone
computer
signals
network
are
that
transmitted
usually
from one
spans
subscriber
a
to
city
another
or a
subscriber.
large campus.
That is a
So,
twisted
to
pair.
connect an
And
entire city, we
its
use
applications.
metropolitan
Most
area network.
common medium,
The cable
telephone network
TV
between
system,
house
it
and
works
local
based
exchange.
on metropolitan
Okay.
area network.
Twisted pair
A
is
MAN
one is
usually
a
interconnects
very
a number of
easy
local
to
area
maintenance.
network
Okay.
using a
At any
high
time we can
capacity
insert or at
backbone
any time we
technologies.
can
A
remove
MAN,
the
it connects group
cables
of
in the
LANs
telecommunication
such
department.
as fiber optic
So that is
link
a
and
common
provides
medium.
uplink
Telephone
services to
network
wide area
between house
network
and local
or
exchange.
WAN
That is
and other
subscriber
internet.
loop
So,
within buildings to private branch
telecommunication
exchange.
department,
Certainly within
cable
building
TV,
we can use it.
network,
Okay, or between house we
cable,
can use
cable
twisted
modem.
pair to transmit
These are the
analog
applications
signal.
for
Twisted pair is
metropolitan area
transmit
network.
only analog
It
signal.
connects
That is
only
voice
major
signal.
cities.
For local area
So, a
network,
company, it
at
has
10
different
Mbps
many
or 100
branches in a
Mbps.
country.
Transmission
Okay,
speed
to
10
connect all
or
branches,
100 megabit
they
per
use
second.
metropolitan area network.
Advantage. Okay, cheap. Twisted pair cable is very cheap and easy to work with cable.
Next,
low data rate and short range.
Wide
For
area
short
network.
range we can
As
use
the term
twisted pair
implies,
cable.
a WAN
That is
spans a
advantage
large
and
physical
disadvantage.
distance. The
Short
internet
rate
is the
one,
largest
data rate
WAN
is very
and
low
spanning
and
the
short
earth.
range.
A WAN is a geographically
cheap
dispersed
and easy
collection
to
of
work.
lands. So, the wide area network, it connects continents, different continents.
Twisted pair transmission
Or it connects
characteristics.
entire world.
Analog amplifiers every
So,
5
a
kilometer
system
to
or
6
computer
kilometer.
connected in the
Digital
wide area network
use
is
either
called
analog
host.
or digital signal.
That is
Repeated
internet.
every 2 kilometer
Okay.
or 3
So,
kilometers.
WAN,
Okay. Limited
the
distance.
internet is the
Limited
largest
bandwidth,
wide
1
area network
megahertz.
spanning
Limited
the
data
earth.
rate.
It connects
Only it
entire
accepts
span.
data up
A
to
wide
100
area
megahertz.
network is a
More than that,
geographically
it will not
dispersed
accept.
collection of lands.
Susceptible
A
to
network
interference
device
and noise.
called
Okay?
a router.
So it is subject
A
to
network device called
interference
a
and noise.
router
That is
connects
twisted
local
pair.
area network to
Okay.
a
So
wide area
interference
network.
are there
WAN, it
noise
connects several MAN and
signal
several
also there.
LAN. It connects LAN and MAN. It is called a wide area network. In IP networking,
Near end
the
crosstalk,
router maintains
coupling of
both a
signal
LAN
from
address
one
and
pair
a
to another.
WAN address.
So the crosstalk is available.
So these are three types of
in
network.
twisted
Local
pair
area
transmissions.
network,
We cannot
metropolitan
avoid
area network,
crosstalk.
wide
Coupling
area
of
network.
signal from one pair to another. Coupling takes place when transmit signal entering the link couples back to receiving pair, and near transmitted signal is picked up by near receiving pair. So we have to maintain some distance. Otherwise, crosstalk it will we have to receive crosstalk.
That is a difference between local area network and wide area network. Diameter of
so there are
not
two types
more
of
than
twisted pair:
few kilometers.
unshielded twisted
Diameter
pair
of
and
not
shielded
more than
twisted
few
pair.
kilometers.
So unshielded
So
twisted pair,
here
that is UTP.
span entire
At both
country,
end are open.
entire country
that
or
is
entire
unshielded
earth.
twisted pair.
Second
Ordinary
one,
telephone wire,
data rate of at
cheapest,
least
easiest
several
to
megabit
install,
per second.
and suffers
Nowadays,
from external
data rate is several
interference.
Gbps, gigabit per
external
second.
medium
Okay, data
interference.
rate less
Ordinary
than
telephone
1
wire,
megabit per
cheapest,
second.
easiest
Nowadays,
to
it
install,
is in
suffer from
several
external
Mbps.
EM interference.
Data rate is
That
very
is
Mbps.
UTP,
And
unshielded
third one,
twisted pair.
and sealed twisted pair, metal bright
the land
or
it is
steel
maintained or
that
owned
reduces
by single
interference.
person or
In
single
unsealed
organization.
twisted pair,
But
STP,
man
at
owned by
one end is
multiple
connected,
organization,
at
wide
other
area
end it will be
network,
open.
it is
That is
maintained
UTP.
by
In
multiple
STP,
organization.
that is in
Very
UTP,
low error
unsealed
rate.
twisted pair,
Error rate is
at
very
both
low.
end
Here
cables are open.
high error
So that
rate
is a
is very
difference
high
between
because
UTP and
in
STP.
wide
Metal
area
braided
network
or CP
data is
that
transferred
reduces
through
interference.
wireless.
So there
In
is a
local
thick
area
metal,
network,
that metal reduces, avoid the crosstalk, okay, and more expensive, have harder to handle. So which is a thousand number of cables are bundled in a single sheath. So that is the harder to handle. Next, UTP categories. There are different category of UTP the cables. Category 3, category 4, category 5, category 6, category 5E, category 7s.
Sir, your mic got muted, sir.
Category 3 twisted pair up to 16 MHz.
network
Voice
topology
grade found
is the
in most
layout
offices.
pattern of
Twist length of
interconnection
7.5
of various
centimeter to 10
elements.
centimeter.
So
Category 4
layout
up to
topology
20
means
MHz. So
layout of
there are
network.
different type
That
of
there is a
twisted pair.
cables,
So
node,
one
links,
category
connection
3
of
it is used for
nodes.
telephone
The
system,
connection
and category
is
4 is
provided through
5, 6
cable.
used for
Okay, the
internet.
entire cable
Okay, so for
structure
different
is called
applications we can
topology.
use
Depending
different
on the
category of
space,
UTP cables. Category 3 up to 16
depending
MHz.
on the
Voice
space or
grade found
premises
in most
available,
offices.
we can
Twist
form
length of 7.5
form a
centimeter to 10
network
centimeter.
within a
Category
room,
4 up to 20
within the
MHz.
apartment,
Category 5
in
up to
multi-storied
100
building,
MHz.
in a
Commonly
very large
pre-installed
campus,
in new
we can
office
form a
buildings.
network
Twist
cable
length
structure.
0.6
That cable
centimeter to
structure, that cable
0.85
pattern
centimeter.
is called
Category 5E
topology.
enhanced.
So
Okay,
depending on the
category 6
spaces
and category
available,
7. So these are different
we
category
can
of UTP cables are
different
available,
type of
sir, for
topology.
high data rate.
Okay,
For,
depending on the
for
spaces
higher
available,
bandwidth,
we can use
we use
different type of
category 6,
topology.
category 7 UTP cable. For
That is
larger apartment, we use category 6 and 7 UTP cable. Comparison of shielded and
These are
unshielded
type of
twisted pair.
topology.
Okay,
Star
so frequency
topology,
1 megahertz. At 1 megahertz,
bus
UTP
topology,
category 3
ring
is
or
used.
circular topology,
Okay, attenuation
tree topology,
2.6
and graph
decibel per
and mesh
100
topology.
meter.
There are
Category
various
5
topologies.
2.0
Depending on the
decibel
premises, we
and
can use
1.1 decibel per 100 meters. And category 3 UTP there is
star
near end
network
crosstalk
or star topology
41,
or
and
one of the most
category
common
5 62
ethnic
150 ohm STP
computer
58
network topologies.
near end
In
cross
its
58 decibel near end crosstalk at 4 megahertz
in its
5.6
simplest ones,
4.1 and
in its
2.2
simplest form,
in category
a star
3 5
network
ohm
consists of
STP
one
and
central
UTP 32 and UTP 5 53 and 150 ohm STP 58 decibel per at 150 ohms
star network
and
or
16
one of the
megahertz.
most
There
common
are
computer
various
network
range.
topology.
25 megahertz various
In
range.
its simplest
100
form,
megahertz
a
various
star
range.
network
300
consists of
megahertz
one
various
central
range. So there is a comparison
switch,
of
hub
shielded and
or
unshielded
computer.
twisted
So
pairs.
there may be a central switch or hub in the
So
star
UTP
topology,
means
which act as a conduit
unsealed.
or to transmit
STP
data,
means sealed
to transfer
twisted pair.
messages or data. The hub or leaf node and
Next,
transmissions.
bandwidth.
16 lines
megahertz,
between
category
them
3, 100
form a
megahertz,
graph
category
with the
5,
topology of a
100
star.
megahertz,
So that is
category
a star
5E,
topology.
category 6,
which is a central hub.
200 megahertz,
Okay.
category 7, 600
Central
megahertz.
hub. These are the
Cable type
computer nodes.
UTP.
So
Category
through
5,
central hub,
UTP,
data
FTP.
will be transferred
UTP
from
or
one
FTP
system
can
to
be
another
used.
system.
Category
No
5E,
data directly
UTP or
transferred
FTP.
from one system to
Category
another
6,
system.
UTP
Through
or
hub
FTP.
only.
Category
Data it will be.
7,
So the
that is
a computer,
SSTP.
it send
Yield cost,
data to
Cat
hub.
5 is
The hub,
equal to
it
1.
can forward a
0.7,
data to
category
another
3.
one.
1, category 5. Category 3, 1.2. 1.5, category 6. Category 7, 2.2. So far we discussed twisted pair cable. Now we move to coaxial cables.
Ring topology, star topology, bus topologies. A configuration that connects all nodes in a closed loop on which messages travel in one direction. The data it will travel in one direction, that is ring topologies. Okay, in a circular manner, systems are connected. Okay, so there will be a small token. That
Display
token
comes,
is circulated on the path of the
student,
topologies.
display comes.
So if any one system transfer a data, it should capture a token. எந்த சிஸ்டம் டேட்டாவை ட்ரான்ஸ்ஃபர் பண்ணணுமோ அந்த சிஸ்டம் டோக்கனை கேப்சர் பண்ணணும். கேப்சர் பண்ணாதான் டேட்டா ட்ரான்ஸ்ஃபரை இனிஷியேட் பண்ண முடியும். கேப்சர் டோக்கனை கேப்சர் பண்ணாம ட்ரான்ஸ்ஃபரை இனிஷியேட் பண்ண முடியாது. So once data transfer is completed, the token is released by concerned node
local area
or
network
computer.
or
next
cable TV network. So that structure of coaxial
a configuration that centers around one node,
okay,
to which
and
all others are connected and through which all messages are sent.
Outer sheath means
okay, so
thick plastic sheet.
all a configuration that center around one node to which all others are connected and through which all messages are sent. So in a central hub,
insulated.
all the systems are connected to the hub. Okay,
and
so any system it want to transfer a data, first it send a data to hub. From the hub, data is sent to the intended recipient, that is star topology.
One is
next bus topology,
end view,
all
another
nodes
one is
are connected to a single communication line that carries messages in both directions through single cable. And all the computer, more than one computer or node, it is connected.
Outer conductor is braided.
This example, ring topology,
and inner conductor is solid metal.
Star topology,
that is a metal
here only
cables,
one hub
separated by insulating materials, covered by padding. Applications of coaxial cables. Most versatile mediums.
Through hub, data is transferred to star topology.
Versatile medium
and bus
means,
topology.
So that is
there is a single communication cable. Through one cable, several computers are connected, interconnected. In star topology, there is a centralized
telephone
system,
communication
computer
department,
or
communication device.
Node,
so these are the
data
most
it will be forward from one point to
television distribution.
Ring topology, there is a token
TV, cable
is
TV.
in the on the path of a ring.
Telephone transmission.
If any system want to receive a send a data,
voice calls simultaneously,
capture a token,
being replaced by
make a
fiber
data
optic.
transfer.
Coaxial
Once
cable
data
is
transfer is
replaced by
completed,
fiber optic cables.
the token it will be released by concerned
we can
system.
use either coaxial cable or
That is
optical fibers. Short
ring
distance
topology, star
system
topology.
links for short communication, for short distance transmission, we use coaxial cables. Local area network.
That is internet connection. Internet backbone, a set of high-speed networks that carry internet traffic. A set of high-speed network that carry internet traffic. These networks are provided by companies such as AT&T, GTE, and IBMs. Internet service provider ISP, a company that provides other companies or individual with access to the internet. Okay, like BSNL, Geo, or Airtel. So they are a ISP, internet service provider. So a company that provides the ISP, it provides internet access to other company or individual. There are various technologies available that we can use to connect a home computer to the internet. How we can connect our system, our home computer to the internet. So there are various technology. A phone modem converts computer data into an analog audio signal for transfer over a telephone line, and then a modem at the destination convert it back again into data. Okay, so at home, that is 10 years back, we use only the dial-up connections. So our system is connected to the phone cables.
So the coaxial cable
at the other end, the phone
most
cable
versatile
is connected
medium,
to the
television
ISP.
distribution,
Okay, between
aerial
ISP
to TV,
and home,
cable TV.
there will be a,
Okay,
a
these are the
modem.
applications
So this
of
modem,
coaxial
it
cables.
convert an analog signal to digital signal.
Long distance telephone transmission can carry 10,000 voice calls simultaneously, being replaced by fiber optic. Short distance computer system link, local area network. So these are the applications of coaxial cable. Versatile medium, television distribution, and long distance telephone transmission, short distance computer system link, that is
So
more
2 3 years
modem,
back,
Wi-Fi,
like
how
how
local area network.
home computer is get connected to the
Coaxial
internet
cable,
or web
transmission
servers.
characteristics,
In
analog
every
transmission,
home,
and it
okay,
accepts both
there is a
analog and
telephone.
digital
So that
transmission.
telephone through
Amplifiers
telephone
every few
cable,
kilometers.
computer
Closer
is
if higher
connected to the
frequency,
internet
up to
server
500
or web
megahertz.
servers.
So that is
is called the
analog. So
dial-up
for
connections.
analog signal,
Okay,
amplifier
so
is
dial-up
required
connection means
to
at a
regenerate
time
a signal
either we
every
can
few
make a
kilometers,
call or
and
we
closer
can
if
do surfing on the
for
net.
higher
So
frequency.
after
It is very
that,
closer for
there is
higher
a
frequency. It can
broadband
transmit up
connections.
to 500
In
megahertz
broadband
signals.
connections, at
Digital
a time
transmission.
we can make
Repeater is
a phone
required for
call
every
as
1
well as
kilometer.
we can
Closer
surf
for
on the
higher
net,
data rates.
internet.
So both
So
analog
these
and digital
facility are
transmissions are available
in the
coaxial cables. In twisted pair cable, analog transmission is only available. Okay, with the help of
that is
modem,
a
digital transmission
DSL
is
or
available.
broadband connection.
So that is
So,
the difference between
first
twisted pair
we
and
used
analog
dial-up
coaxial
connection.
cables.
Second, when we use
Next,
broadband. Third
optical
one, we
fibers,
use DSL.
core,
A digital
jacket,
subscriber
and
line
claddings.
uses
Okay?
regular
So
copper
glass
phone
or
line
plastic
to
cores.
transfer
So,
digital
so
data
that is
to
so
and
here
from
core
the phone
means
company's
that is
central
the
office.
thin glass
So the
fiber
DSL,
cable
DSL or
is made up of
ADSL.
thin
There are
glass.
two advanced
Fiber cable
technique.
is made
We
up of
connect
thin glass.
phone
So that is
to the
core, glass core.
computers
jacket.
via phone.
Jacket means there is a
connect to
protection.
our system into the web servers.
The
So
plastic
in
sheet,
earlier
protected
days we
plastic
used
sheet.
broadband
cladding,
connection
that is
and
also
dial-up
a
connection.
After
After
that
that, we use
materials.
DSL
So these are
or
the
ADSL,
outer protections,
digital
jacket
subscriber
and
line.
cladding.
ADSL
So the
means
glass or
asynchronous
plastic cores,
digital
that is
subscriber
a
lines,
cables. Here
which
plastic
connect
or
our
glass
phone
core,
to the
laser or light emit
computer.
diode.
Then it
So
will connected to the internet servers.
it
Third
accepts
one,
signal,
cable
light
modems.
signal.
A cable
So what
modem
kind of light
uses
signal?
the same
LED
line
or
that our
laser
cable
light.
TV
Specially
signal
designed jacket. Small size
comes
and
in
weight.
one in
So
on
it
to
is
transfer the
small in
data
size
back
and
and
weight.
forth.
So next thing,
So
fiber
the
cable, it has two modes, single mode
cable
fiber and optical
television operator,
multi-mode
they
fiber.
use cable
Single mode
modem.
and multi
Okay,
mode.
first they
So
use
in
cable
single
modem
mode means
to
when
provide telecasting
ray, light ray
or
is transmitted in a single
TV
medium.
programs.
Air
After
to
that,
air,
they use
water to
this
water.
antenna.
It
Nowadays,
transmits in single
every
medium.
cable TV
It is
operator
in
has one
it travel
or
in
many
single mode fiber.
this
So
antenna.
when
Through
ray
this
it
antenna,
transmit
they
from
connect
one medium to another, from water to air
our
or
computer
air to
to
water.
the internet.
So it take
Okay,
different
so there are
bounds.
various
It take
technology,
different
phone
bounds.
modem
So that is
and
a
DSL
multi-mode.
and cable
Multi-mode is
modems.
required
So before
when
that, we
light
use
ray travel from one medium to another
dial-up
medium.
connections
Single
and
mode is
broadband
required
connections.
when
After that,
light
DSL,
ray travel
ADSL,
in a
and
single
also
medium,
digital
air
subscriber
to
line
air or
and
water
cable
to water.
modems.
So that is a two types of mode, single mode and multi-mode fiber are available. So that is
Another
an
one, broadband.
angle of incidence,
broadband,
angle of reflection.
a connection
So
in
the
which
right
transfer
ray, it will
speed
be
or faster
refracted
than
at particular angle,
28
and
bits per
right
second.
ray is
DSL
reflected
connection and
reflected
cable
at
modems or
particular ray.
broadband
So, okay,
connections.
beyond the
DSL connection and cable
angle,
modem
the
both
ray,
are belongs to
it will light
cable
ray, it will be reflected
broadband
at
connections.
particular
The
angle.
speed for
That light ray,
downloads,
it will be refracted.
getting data
when
from internet to your
light ray is
computer,
entered
it
from
may
one
not
medium
be
to
the
another
same
medium,
as
ray it will
uploads.
be refracted.
Okay, from
Okay,
your
so light
computer
at less than
to the
critical angle
internet.
is
So
absorbed
here
in
the
jacket.
download
So that
speed
is
and
angle of
uplink
incidence,
upload
angle
speed
of
is very
reflection.
important in the
So incident means
internet.
when ray
If
touches
download and upload
the boundary, that is
speed
incident.
or capacity
Reflection
is increased, we can transfer
more than
any size
critical
of
angle.
data.
It will be reflected. Ray, it will be
That is
reflected
100
at
GB
the
data, 50 GB data, 1
more
terabyte
ray, it will
data,
be
it can be
reflected
transferred.
at more than
Depending
critical
on the
angles,
speed,
more than
if
180
speed is
degree angles.
high, we can transfer more amount of
That is
data.
benefits.
If
Optical
speed is
fiber
very
benefit.
low, we
Greater
can transfer
capacity,
through
data
high
rates of hundreds
of
of
data.
Gbps, smaller size and
Next.
weight, lower attenuation, electromagnetic
இப்போ
isolation,
கவனிக்கிறீங்களா?
greater repeater spacing, 10 seconds of kilometer
So,
at least. So greater
கவனிக்கிறீங்களா?
capacity, smaller size, lower
Yes, sir.
attenuation, electromagnetic isolation, greater repeater spacing. So these are the benefits. In twisted pair and coaxial cable, attenuation is high. Here attenuation is low. So here it accepts electromagnetic signal is isolated. Okay, it accepts only light ray. So greater repeater spacing. Repeater spacing is greater, 10 seconds of kilometer. At least for every 10
to
seconds of
improve the
kilometer,
efficiency of transferring
repeater
information
spacing is
over
required.
a shared communication line, messages are divided
Application
into fixed size,
of
numbered
long-haul
packets.
trends,
That means how we
metropolitan
can
trends,
improve the
rural
efficiency
exchange
of
trends,
transferred
subscriber loops,
information.
land.
So that means
These are the
to
fiber
improve the
optic
efficiency
cables
of
are used
transferring
in this
information
application.
over a shared
long haul
communication line,
means
messages
STD
are divided
or
into
ISD.
fixed size,
Metropolitan trend,
numbered packets. So the
metropolitan trend
entire
means
message,
STD,
it will
long
be
haul
divided
means
into several packets,
ISD.
100
Rural
packets or 200
exchange
packets
trend,
or 300
subscriber
packets.
loop,
Okay,
LAN.
every day every day
Optical
you can
fiber
collect
transmission characteristics act as waveguide for 10 power 14 to 10 power 15 hertz portions of infrared and visible spectrum.
we can improve
Light
the
emitting
transferring
diode
speed.
LED,
The network
cheaper,
devices called
wider
routers
operating temp
are used
range,
to direct
last
packets
longer,
between
injection
networks.
laser
So
diode,
here we use
ILD, more efficient, greater data
routers
rate,
in
wavelength
local area
division
network, in
multiplexing.
metropolitan area
Okay,
network.
so these
We
are the
use
characteristics
router.
of fiber
So that
optics.
router it
Act
directs
as
packets
waveguide for 10
between
power
the
14 to
networks.
10 power
For
15 hertz.
example, okay,
And it
so for
accepts
system 1
LED,
and
light
system
emitting
2,
diode.
we
It
are
is
not
cheaper, wider operating temp range, last longer. Injection laser diode, ILD, more efficient, greater data rate. Wavelength division multiplexing. For wavelength also, fiber optic cable is used.
network devices called routers are used to direct packets between
That is a
networks.
step index
Each
multimode,
message
graded
it
index
consists of
multimode,
50
single
or
mode.
100 packets. These
As I told,
packets
that is it
are
travel in a
routed independently in a computer
medium,
network.
air to
Okay,
air.
before
Graded
reaching
index.
the
Okay, it
destination,
will take
all the
different
packets
bounds.
it will
It
be
will take
assembled.
different bounds.
Okay, then it will be delivered
In
to
multi-mode,
the
two types,
destination.
step index and
Okay, these
graded
are the
index.
how the
Okay,
data it will be
take different
delivered
bounds.
in the
Output pulse, output pulse.
network devices. That for example,
That is mode of fiber mode, fiber optic
source
cable.
it sent a message. This message split up into packet 1, packet 2,
Frequency
packet 3.
utilization for fiber
This packet
application.
1, 2, 3,
Wavelength
it
in
will be
vacuum
sent to
range,
other
820 to
recipients.
900.
There also
Frequency
N into
range,
N
366
users.
to
For
333.
10 users,
Fiber type
10 input
multi-mode.
user, 10 output
Application
user.
local area network.
Okay,
For local
here
area
3
network, we use
packets
multi-mode fiber.
transferred to
Wavelength
destination.
1280,
From the destination, it transferred to
1280 to 1350. Frequency range 234 to 222. Band label S.
packets
Single
between
mode
networks.
various.
Network devices called
1528 to
routers are used to
1561.
direct
196 to
packets
192.
between networks.
Band label C.
Here,
Single mode WDM.
system send a message. That message
1561 to
divided into 3 packets.
1620.
That packet
Frequency
1
range 185 to
is
192. Band label L.
reached to
Single
packet
mode
here
WDM.
packet 1, packet 2
Wavelength
it reached
division
to their packet 2, packet
multiplexing.
3 is reached to packet
here
3.
a single
Then
mode fiber is used
these
for
information from the packet are
wavelength
reached
division
to the
multiplexing and
receiver
various applications.
recipient.
Local area network multi-mode fiber is used. So these are the frequency graph, twisted pair graph. How it
Next,
transmit a data
open system.
and wavelength
Here
in
open
vacuum
system means
and frequency
between
coaxial
two
cable
entity
transmission
data
and
is transferred from one
composite
system
graph.
to another system.
Okay.
Between two entity data is transferred from one system to another system.
So far we discussed physical transmission
Bhuvaneshwari.
medium. Next, wireless transmission mediums. So all of you listening?
Yes, sir.
Okay.
Proprietary Yes, sir. system, interoperability system. What is mean by proprietary system? A system that uses technologies kept private by a particular commercial vendor. One system could not communicate with another, leading to the need. So here proprietary system means a system that uses technologies kept private. One technology is kept private by a particular commercial vendor. For example, Microsoft Office, which is a product
Wireless
of
transmission frequency.
Microsoft Office,
2
a product
gigahertz
of
to
Microsoft
40
Corporation.
gigahertz. It transmission
If we
speed
want
from
to
2
use
gigahertz
Microsoft
to 40
product,
gigahertz.
MS Office,
Microwave,
okay,
highly
and also
directional,
Windows,
point-to-point, satellite,
Windows
30
OS, Windows
megahertz
10.
to 1 gigahertz.
So, to
omnidirectional
use these
broadcast
software,
radio,
we get
3
prior
into 10
permission
power 11
or
to
we
2
get
into 10
license
power
from the
14.
proprietors.
Infrared,
Okay, so that is a
local.
proprietary
Okay.
system.
So wireless transmission
Interoperability.
frequencies 2 gigahertz to 40 gigahertz. So at
What
this
is mean by
speed,
interoperability?
microwave,
The ability
highly
of
directional
software and
point-to-point
hardware
satellite
on
can be
multiple
used.
machines
From 30
and from
megahertz to
multiple
1
commercial
gigahertz.
vendors
Radio
to communicate.
broadcasting, it can be used.
So there
And
are
3
different
to
machines.
10 power 11
Each
to 2
machine,
2
it
into 10
has
power
its own
14.
format.
Infrared and
It
locals.
has its
These
own
are
coding
the
system
different
and everything.
wireless transmissions
Similarly,
are possible
another
at
system,
different
it belongs
frequencies.
to different vendor and different coding systems. So to communicate these
Antennas,
two systems,
electrical
there is
conductor
a common
used
pattern.
to radiate
That is called
electromagnetic energy or
interoperability
collect
software.
electromagnetic
We
energy.
can use
So
our
we use antennas at in the
two-wheeler
top of the
in
building.
any
Why we
one
use
of the
antenna? To receive electromagnetic signal
oil
at
companies,
particular
petrol
directions.
bunks.
At
So
particular
the
direction,
ability
we
of
can receive
software
electromagnetic
and hardware
signals. So through
on multiple
antenna,
machines
the
and from
signals
multiple
it will be
commercial
received
vendor
and
to
sent to
communicate.
the
So
via
the
cable
different
to
software,
televisions.
different
So
hardware
20 or
is
25 years
supported
back,
by
in
the
each house there is
interoperability
a antenna.
software.
Through
A single
antenna
system,
only
it
signal
has
it will be absorbed
Unix,
and
Linux OS
sent
and
via cable
Windows
to
OS.
televisions.
Okay, so
Nowadays
both operating
satellite
system, it works
these
different
antennas available. Okay, through
coding
these
systems.
antennas,
Okay,
it
and number
captures
of bits
signal and
transferred
sent
bit
to the
and accepted bit, it will be
television
different. So
through
to
cables. There is no
communicate
need
both
of
operating
separate
system,
antenna
we need
for every
common
house.
interoperability
So
software.
through
Another one, open
this
system.
antenna, it will
Systems
send to the
based
server.
on a
From
common
server,
model
it
of a
goes
network
to every
architecture
house.
and a
So
suite of
electrical
protocols
antenna means
used in its
electrical conductor
implementations.
used to radiate electromagnetic energy. It
So
will
open
radiate
system means
electromagnetic
between
energy
two
or collect
open entities,
send or
data
collect
transfer, it can be
electromagnetic
possible
energy.
or it can be
Transmission,
achieved.
radio
That is called
frequency energy from
open
transmitter
systems. So
converted
first
to
one,
electromagnetic
proprietary
energy
system.
by
So we
antenna
get permission from
radiated
the
into
concerned
surrounding environment.
proprietor. Interoperability.
Through
To
antenna,
make
the
use
radio frequency
different kind of
energy
OS,
from
different
transmitter,
software
from
of
transmitter it will
computer.
accept
We
and converted
install
to electromagnetic
interoperability
energy.
software and
Radio
open
signal
system.
converted into
Between
electromagnetic
two open
energy.
entities,
And
we
through
can transfer
antenna
data
radiated
from one
into
system
surrounding
to
environment.
another system.
Reception, electromagnetic energy impinging on antenna converted to radio frequency electrical energy fed to receivers. Same
So
antenna
OSI
often used for both.
layer is the
So we can use
open
a
system.
transmitter. That
The
transmitter
international
it
organization
able to transmit or accept a signals, electromagnetic signals. Radiation pattern,
Open
power
system.
radiated in all
The
directions,
international
not same
organization
performance in
for
all
standardization,
directions. Isotropic antenna
established
is
the
point
open
in space,
system
radiates
interconnection
in all
reference
directions
model,
equally,
OSI reference
gives
model.
spherical
Each
radiation
layer
pattern.
deals with a particular aspect of network
Parabolic
communications.
reflective antenna.
Okay.
So
The
in wireless
OSI reference
transmission,
model,
we use
it
different
has
antenna
7 layers.
to
Physical
send a
layer,
signal or receive
data
a
link
signal.
layer,
So the
network
previous
layer,
one,
transport
radiation
layer,
pattern,
session
power
layer,
radiated in all
presentation layer,
direction, not same
application
performance in
layer.
all direction,
Okay. So
isotropic
on
antenna.
the
Okay,
recipient
now
side,
parabolic
the data
reflective antenna
it passes
used
through
for
7
terrestrial and
layers.
satellite
Okay,
microwave.
and reach the and
So
through
we use
cable it
terrestrial
the data is
communication and
transferred
satellite
and reach the
communication.
host
Parabola is
or recipient.
locus of point
From the
and
sending side,
equidistance
data
from a
is
line
processed
and a point
through
not
7
on
layers.
that line.
On the recipient
Fixed
side,
point is
data
focus.
is processed
Line is
process
direct
through
treatment.
7
That is
layers.
parabola.
Then it reaches
So parabola is
the host
locus of point
computers. So at both
equidistance.
end,
At
data
particular
is
point, it will be at
transferred
equal
through 7
distance.
layers.
At
So
signal, it
the
will be
number of
transmitted
layer,
from
function
line
of
no,
layer,
and a
okay,
point
is
not on
differ
that
from
line. From one line to another
system to
one.
systems.
Revolve
In OSI
parabola
layer,
about
I
axis
think there
to
are
get
7 layers
paraboloid.
in OSI system.
Cross section
That
parallel
is
to axis
OSI
gives
reference model.
parabola.
There are 7
Cross
layers.
section
In
perpendicular
TCP/IP
to
reference
axis
model,
gives
there are
circle.
5
Sources
layers.
placed at
In
focus will produce waves
ATM reference
reflected
model,
from
there
parabola
are
in
3
parallel to
layers.
axis.
So the function
Creates
of layer,
parallel beam of light,
number of
sound,
layers,
radio. On reception, the signal is concentrated at focus where the detector is placed. So there is a pattern of parabolic dish antenna. So that is a structure, parabolic structure. So direction, so it is reflected in on that line, okay, it's a parabola. And the second one, cross section of parabolic antenna showing reflective property.
Sir, will you provide with PowerPoint, sir?
yes.
In official website,
Antenna
sir?
gain, measure of directionality of antenna.
Which one?
Power output in particular direction.
The PowerPoint
Compared with that produced by isotropic antenna. Measured in decibels.
I will send your
results
mail.
in loss
Any
in
one of
power
them.
in another direction. Effective
Sir, it's my
area
mail
relates to size
You
and
chat, sir.
shape.
You can share to other
These are the
other
gains.
students.
So what is the gain of antenna?
I'll put it
So
in chat, sir.
directionality, we can
My mail ID.
measure the directions.
Yes.
From which
Yes.
direction
I will be
a
sharing,
signal
sir.
is
You can put in
received.
chat box and
Power
I will
output
send
in
you.
particular direction
Thank you, sir.
compared with that produced by
So,
isotropic antenna. That we can input power.
எப்படிங்க?
Power output should be put. Okay. From received
no
from
problems,
isotropic
but
antenna.
disturbance.
The
I
signal
have some
it will be
disturbance from
measured
your
in
side.
decibels. Results in loss.
Some of
in
you
power
joined
in another
late,
direction.
and some of you
so it will be
talking.
sometimes it will be loss.
That is-
effective area
there is a disturbance
relates to
from your
size
side.
and shape.
So that I have to change the screens.
In wireless transmission, we use terrestrial
Yes.
microwave.
No problem.
So this terrestrial microwave, it
Sir, I have sent
uses
my mail ID through
parabolic
chat,
dish,
sir.
focused
BCA I will
beam,
send,
line
sir.
of
Full
sight,
group.
long haul telecommunication, higher frequency, give higher data rates. These are different
Sir, I have
ways
sent my mail ID,
of
sir, through chat.
transmitting a signal in microwave transmissions.
Okay, I will send
so
later.
through parabolic dish, it can transmit a signal, or focused beam, or line of sight, or long haul telecommunication, long distance telecommunication, or higher frequency, give higher data rate.
Okay. So each layer
Second one,
deals
satellite
with a
microwave.
particular aspect of network communications. I think each layer. So each layer it has well-defined function. Well-defined function. After performing a function, it send it to upper layers.
Satellite is relay
The
station.
first on
Satellite
the
is a
sending
relay
side,
station.
a system, it sending
Satellite
a data,
receives
it
on
submit
one
a data
frequency,
to application
amplifies
layer.
or
Application
repeats
layer
signal
perform a
and
function.
transmit on
Then
another
it submitted to
frequencies.
presentation
So that is
layer.
the
Presentation layer it
characteristic
perform
of
function
satellite.
submitted to session
It
layer.
receive on
So,
one frequency
and so
and
on.
transmit
Like
in
that,
another
until it
frequencies.
reach the physical
Required
layer.
geostationary
So one
orbit,
layer it
height
perform
of
function and submitted to below layer. This is the method on the sending
long
side.
distance telephone calls and private business
data
networking.
is
These are
reached
the
to the physical
applications
layer.
of satellite.
The physical layer
Transmit
it
television broadcasting,
transfer a
long distance
data
telephone
to the
and
corresponding
private business
physical layer
networking.
on the
For this application, we use satellite
recipient
microwave.
machines on the receiving machines. Okay, so in the on receiving side, physical layer perform a function submitted to data link layer. Then it will be submitted to network layer. Then it will be submitted to transport layer. Finally, it will reach application layer.
It accepts
on
in
the
one frequency
application layer of
and send
recipient
on another frequency to the
then
earth station.
application layer submit
to
completed
it will not
message
directly
to
communicate
the host
through
B,
satellite
host
it
B
or
or
receive a
recipient
signal.
machines.
That is
So these are the
point link.
procedures.
That is broadcast link. The multiple receiver, one sender, one transmitter, and multiple receivers. So from one station, signal is sent to the satellite antenna, and that satellite send a signal to multiple stations. That is one sender, multiple receiver. That is a broadcast link. This is point to point. That two station it can communicate through satellite, point to point. Here a broadcast link, one sender and multiple receiver. Radio broadcasting. Radio broadcasting is omnidirectional. Okay, and it is used for FM radio. It uses UH, ultra high frequency and very high frequency television network. Line of sight suffers from multi-path interference, reflections. Modulate non-coherent infrared light, line of sight or reflection blocked by walls. Example, TV remote control, IRD port. TV remote control, IRD port are used for infrared communications. Line of sight blocked by wall, modulate non-coherent infrared light. Wireless propagation. Signal travels along three routes. Ground wave follows center of earth up to 2 megahertz AM radio.
OSI reference model, services in the OSI
BBC
model.
World Service, Voice of America.
OSI reference model is an internationally standardized network architecture.
Layer of upper atmosphere.
OSI means open system interconnection. It deals with open system, that is systems open for communication with other system. Between two open entities, data is transferred. That is called the open system interconnection. Specified in ISO 7498.
It routes via
it has 7 layers.
Counter of earth up to 2 megahertz AM radio.
That is layer 7 application layer, layer 6 presentation layer, layer 5 session layer, layer 4 transport layer, and layer 3 network layer, 2 data link layer, and layer 1 physical layer. So layer
direction to another direction. That is line of sight.
Relate to communication technology. Layer 5 to 7 relate to user applications.
About 30
here layer 1, 2, 3, it will be work in within the network. Within the network, layer 1, 2, 3 it work. So outside the network, across the network, layer 4, 5, 6, 7 it will works. Okay, but layer 1, 2, 3 are enough to work within the network. Okay, layer 4, 5, 6, 7 are enough signal to work across the network. That means one network to another network. To connect one network to
ground
another
wave. To transmit a signal at every 50 kilometers,
the function of
establish a tower.
Layer.
From
so
one tower
I
to
already
another
said
tower,
each layer it has well-defined
below
functions.
2 megahertz.
Layer 7
if signal it will be transmitted
level
below
at
2
which
megahertz,
applications access network services, represent services that directly supports software applications
This is
for
ground
file
wave
transfer,
propagation.
database
Next,
access, and
sky
electronic
wave
mail.
propagation.
So for
So
this
there is ionospheres.
application,
So from
software
transmitting
applications, it
antenna,
supports
signal
application
sent to
layer,
ionosphere.
database
Then
service,
it will be propagated
data
to
dictionary,
Earth. Then
and
it will be sent to
NNTP, network news
sky.
transport
So
protocol,
before
file transfer
reaching to
protocol,
another
and electronic
tower,
mail.
it will
For
go
these
and come.
application,
It will send and receive
to
from
work with
ionosphere.
these
Then
applications,
finally it
we
will
need
reach to
application
receiving
layer
antenna.
7, layer 7
Okay.
application
So
layer.
from
And
from one
presentation,
tower
what is the
to
function of
another tower, there
presentation
is
layer?
no direct
Related to
communication.
representation
So through
of transmitted
ionosphere
data.
signal, it will
Translate
be
different data
communicated
representation
from one tower
from
to
the
another
application
tower.
layer
So
into
the
uniform
propagation
standard
speed 2
format.
to 30
So
megahertz.
each day
This is
system,
sky wave.
it has its
Another
own
one line
coding
of
system.
sight from directly from one tower to another tower signal, it
ASCII
will be
coding
transmitted.
system,
So there is
EBCD
a
coding system,
transmitter
Unicode
and there is a
system.
receiver.
Each vendor, each motherboard vendor, it
Through transmitter
follows
signal
different
it will be
coding
sent.
system.
Through receiver at the other
data
end, it will
created
be
in one
received.
coding
That is
system
line of sight propagation.
is not supported with another coding system.
Refractions.
To interrelate
Velocity of
these, we
electromagnetic
need
wave
one
is a
data
function of density
conversion
of
method,
material.
data
3 into
structure.
10 power
The
8 meter per
data
second
structure, it
vacuum.
represents
Less in
data
anything else.
in
As wave
its
moves
own
from one medium to
system,
another,
for
its
its own
speed
systems.
changes.
If
Index
we
of
send a
refractions.
data in 5 bit,
Angle of
5 bit,
incidence,
it
sin,
convert
angle
into
of
7 bit.
refraction.
If we
Okay.
send
And
data in
varies
7
with
bit,
wavelength.
it convert into
May
5
cause
bit.
sudden
It
change
represents
of
different
direction
coding
at
system.
transition between media.
And also
May
translate
cause
from one
gradual
type
bending
to
if
another
medium
type.
density is
So
very
this
low.
work is done
Density
by
of
presentation
atmosphere
layer,
decreases
providing
with height,
services for
results in bending
secure,
towards earth of
efficient
radio
data
waves.
transmission. It provides data encryption
So signal
and
is
data
refracted. How it will be
compression.
refracted?
So the data
Velocity of
presentation layer,
electromagnetic wave is a
do
function of
data
density of
compression
material.
work
3
on the
into
sending
10
side.
power 8
On the
meters per
receiving
second
side,
in
data
vacuum.
it will be decompressed.
It will be refracted.
And on the
As
sending
wave
side,
moves
data
from one medium
encrypted.
to
Data
another,
is
its
encrypted.
speed changes.
Okay, it will
Index of
encrypted means
refractions.
it original data it will be
And that is
converted
refractive
into
index.
some
Sin
unmeaningful,
angle of incidence
meaningless
divided
data.
by
That is
sin
encryption.
angle of refraction.
After
Varies
reaching
with
the recipient
wavelength. May
encrypted
cause
data it
sudden
will be
change of
decrypted.
direction
It
at
back to the
transition between
original
media.
text.
May
So that
cause gradual
conversion work,
bending if medium
that
density is
compression
very
work
low.
is done
Density
by
of atmosphere
presentation layer.
decreases with height, results
Layer
in
5
bending towards
session
earth
layer
of radio
allows
waves.
two applications on different computer. Allow two
Optical and
application
radio
on different
horizons.
computer to its
Okay,
established
optical
use
horizons,
and
that is
NDS
here.
session. File transfer,
Optical
remote
means there
login.
is a
To connect to the remote
fiber
login, we
transmission,
need session
fiber optical
layer.
transmission, light wave transmissions.
It
Radio
establishes
horizon
dialogue
means
control, regulates which
electromagnetic
side
signal.
transmits, plus when
Electromagnetic
and
signals.
how long it transmits.
Another one,
When it has
line
to
of
transmit
sight
a data
transmissions.
and
So
how
far
long
we
it has
discussed
transmit a data.
microwave
That is
transmission,
establishes
satellite
dialogue
transmission,
control.
radio
So
transmission.
traffic
Another
regulation
transmission,
that is
line
controlled
of
by
sight transmission,
session
free
layer.
space loss.
Third one, perform token
There is
management
no
and
free space.
synchronization. Okay,
Signal
so that is
disperses
it allowed
with
to
distance.
application
Greater
on different
for
computer
lower frequencies.
to establish to
Atmospheric
use an NDS
absorption.
session. The same
Water
application it
vapor
can be
and
used
oxygen
into
absorb
compute.
radio signal. Water
Second one,
latest
establishes
at 22
dialogue control
gigahertz,
to
less
transfer
below
a
15
data
gigahertz.
and token
Oxygen
management.
greater
Okay,
at 60
which one
gigahertz,
access the
less below 30
resources.
gigahertz.
Okay, there is a
Rain and
deciding
poor
policy.
scattered radio
Policy
waves.
deciding. There are
Multi-path.
multiple systems in a
Better
network.
to get line
Or
of
several
sight
more
if
than
possible.
one system it
Signal
requires
can be
a printer.
reflected.
More than
causing
one system
multiple
it requires
copies
a
to be
scanner.
received.
Okay,
Maybe
so
no
based
direct
on the
signal at all.
priority,
May
which one
reinforce or
access
cancel
first?
direct
Based on
signals.
the priority,
Refraction
all
may
these
result
user
in
has a
partial
token.
or
All
total
the
loss of
users
signal
has
at
been
receivers.
issued
So
token.
for this
So based on
transmission,
the
we
token
need
number, the
atmospheric
system is
absorption,
allowed
we
to
need multi-path,
access the
we need
resources.
refraction,
That is called
and
a
free space loss.
token
So
management
these
and
are the characteristics
synchronization.
of line of sight
Number 4,
transmission.
transport layer manages
So
transmission
traveling
packets,
distance map,
repackages long messages, and when necessary into small packets for transmission. Reassemble packet in correct order to
at
get
one
the
side
original
y-axis
messages.
loss decibel, 60,
it will
70,
be
30, and distance 5
it will be
kilometer, 10 kilometer,
disassemble
50
of the
kilometers.
packet on the sending side
At how many
and
speed
reassemble
it will
of the
be
packet
traveled.
on the recipient side. Okay, and packages and repackages, attaching the address information, trailer
At
information
how many speed
on
it
the
will be
sending side.
traveled.
On the receiving side, it remove the trailer information or header information. Packaging, repackaging.
300
First
gigahertz
one,
from
manages
140
transmission of
decibels
packets. Second
and
one,
10
handles
kilometers.
error recognition
30
and
gigahertz.
recovery. Transport layer
Okay,
at
5 to
receiving
10
acknowledges
kilometers.
packet delivery.
120
It
decibels.
ensures
300
error-free
megahertz
delivery of a
speed.
single
10
message.
kilometers
That is a
at
transport
80
layer.
decibels.
Resend
Distance
missing packet.
x-axis is
During
distance
sending,
and
any
y-axis
packet
is
is lost,
loss. That's
any
in
packet
decibel.
is missed, that packet it will be resent. That is transport
Multi-path
layer.
interference, microwave line of sight,
Network
and
layer
mobile radio.
manages
These are
addressing
the
a routing of
mobile
data
radio.
within
So
subnet.
there is a mobile tower
within the
apartment
network,
and
data it will
buildings.
be transferred.
So from
Data it
your
will be managed.
from your car,
Okay, so
call
it
a
will not require outside.
person through mobile
Addresses
network. The
messages
call
and
it sent
translate
to mobile
logical
tower,
address
and
and
again
names
it
into
reach to
physical
exchange.
address.
Then it comes
Each
to car. Again it goes
host,
to a
it has
buildings.
maintained
So there is
physical
a
address
mobile
and
radio
logical address.
communication. This is
Okay,
first one is a
physical
microwave
address,
radio
source
communication.
ID, and destination ID.
So
So
this chapter
between
is over.
source and destination ID, there are several router ID. Data passes through several routers.
Transmission media chapter is over.
Router ID is called logical address. So the network layer, it has to map the logical address. So addresses messages and translate logical addresses and name into physical address. Determines the route from source to the destination computer. The network layer only decide to which route data has to pass or packet has to pass. Which route is shortest route. Okay, it is decided by network layer. Manages traffic problem. If there is any traffic in the communication channel, or it is congested, data is congested, it will be decongested by network layer. That means that is congestion control. If a traffic problem arises, it will be resolved by network layer. Routing based on static table determined at start of each session, individually determined for each packet, reflecting the current network load. That is, manages addressing routing of data. Second one, routing can be based on static table and determined at start of each tables. Second one, data link layer packages raw bits from the physical layer into frames. So data link layer, it receives data from network layer. So on the receiving of bits, it will be make up into frames. Okay, so on receiving of binary bits, it will be make up into several data frame. Each data frame, it consists of 10 KB or 10 bytes or 100 bytes or 10 KBs. Okay, provides reliable transmission of frames. And it waits for an acknowledgement from the receiving computer. If one frame One frame means several bytes. If one frame is sent to recipient, okay, so after receiving acknowledgement, it send another data frame. Okay, so upon receiving of acknowledgement, the sender it send data frames. The retransmit frame for which acknowledgement not received. If any acknowledgement is not arrived, for that frame, particular data frame, it will be resent. Layer 1, physical layer, transmits bit from one computer to another. Okay, it transmits from one computer to another computer, regulates the transmission of stream of bits over a physical medium. So physical layer only transfer data to another system through transmission mediums. Okay, and regulates transmission of stream of bits over physical medium. How many bits it has to send per second, it defines how the cable is attached to the network adapter, and what transmission technique is used to send data over the cable. That is transmission technique means that is the simplex, half duplex, full duplex. Deals with issues like definition of 0 and 1, how many volts represent 1, how long a bit lost, 0 voltage for off, 1 voltage for on, whether the channel is simplex or duplex, how many pins a connector has, and what function of each pin is. There are different here pin means, so in each printer and modem there is a pin, 25 pin.
The voice is not audible, sir.
சூப்பர் வருது அதான் போட்டு
I think you are muted, sir.
So there are 7 layers in the ரொம்ப நேரமா மியூட்ல இருக்கா இப்போதானா? ஓகே, நெக்ஸ்ட் பிகி பேக்கிங்.
5 to 3 minutes இருக்கும் சார்.
இது வாட்ச் பண்ணீங்களா? இது வாட்ச் பண்ணீங்களா?
எஸ் சார், இது வாட்ச் பண்ணோம். கரெக்டா வந்து அப்ளிகேஷன் லேயர்ல
நெக்ஸ்ட் சாப்டர்
லெவல் 1ல போச்சு சார்.
sliding window protocol. Application layer பாத்தீங்க, sliding window protocol. So we use piggy layer பார்த்தாச்சு.
எஸ் சார், ஃபர்ஸ்ட் லேயருக்கு அப்பதான் கட் ஆச்சு.
இது டிரான்ஸ்போர்ட் இதுவா?
இது இல்ல சார், லேயர் 1.
லேயர் 1. லேயர் 7, லேயர் 6, லேயர் 5, லேயர் 4.
What is mean by picky backing method? Picky backing means on the back. Okay, back
sir,
side.
பண்ணோம் sir.
We can
network layer discuss
one bag.
Yes,
picky bagging. So in most practical situation, there is a need of transmitting data in both directions.
Yes, sir.
In both directions,
Physical
it can
layer கட்டாச்சு.
transmit a data.
Physical layer
This
அப்படிங்கிறது
can be
first
achieved
layer.
by full
But
duplex
sending
transmission.
machine வந்து
Full
last
duplex
layer.
means
Sending machine first starting
when
வந்து application
station
layer
A
தான் sending
sending
machine
a
தான்.
data to
Application
station
first
B,
application layer
at the same
perform
time
ஆகும். Then
station B
application layer
also
என்ன
sending
perform
a
ஆகும்?
data to station A.
email,
That is full duplex
data dictionary,
transmission.
database
At both
connectivity,
side,
file transfer,
station
so இந்த
sending
மாதிரி
a
data
data.
எல்லாம் application layer.
If this is
Presentation
done,
layer
we
என்ன
have two separate
function
physical
perform ஆகும்?
circuit,
Data
each
compression
with forward
and data
and reverse
conversion.
channel. For
And
full
session layer
duplex, we
at
need
remote
two
login connect
separate
பண்றது.
cable
Okay,
or
and
channel. In both
resources
cases,
access
the reverse
பண்றது.
channel
Resources
is almost
access பண்றதுக்கு
wasted.
permission
To
provide
overcome
பண்றது
this
as session
problem,
layer.
a
Transport
technique
layer
called
error free
piggybacking is used.
transmission and
The technique of temporarily
packet
delaying
வந்து,
outgoing acknowledgement so
ensure
that they
பண்றது
can be
transport
hooked
layer.
onto the
Network
next
layer
outgoing data
traffic
stream
routing
is known
வந்து
as
decide பண்றது.
piggybacking. For
Okay,
example,
shortest route
A
decide
is
பண்றது.
sending a data
Congestion
to B.
avoid பண்றது.
Okay,
network
B
layer.
it also want to send a
Data link
data
layer
and
data
also
frame
send
make up பண்ணி
acknowledgement.
within
Okay,
a network
along with
data
data,
transfer
acknowledgement
transfer.
at a signal for
Transport layer
previous
வந்து
one
outside
is
the
also
network.
sent.
Data link layer
Okay,
within the
so
network.
along
Physical
with
layer
data,
it
okay,
transmit
along
bit
with
from
data,
one computer to
that
another. Regulate the
acknowledgement
transmission
signal
of a
also
stream
it
of
will be
bits
sent
over a physical
acknowledgement data for previous one. Okay, both
It
current
decides
data and the previous acknowledgement
network
both are sent.
transmission
That is called
technique.
a piggybacking.
What type of transmission
so
technique?
that technique
So,
of temporarily delaying
parallel
outgoing acknowledgement.
transfer,
Okay,
serial
technique of
transfer,
temporarily delaying
serial transfer and
acknowledgement,
parallel transfer. There are two types of transmission technique.
outgoing acknowledgement,
And
so that they
there
can
are
be
three
hooked
types
onto
of
the next outgoing data frame.
channels.
Is known as
Duplex channel,
piggybacking.
pop duplex
However,
channel, full duplex channels.
Piggybacking introduces a complication not present with
How
separate
much volt
acknowledgements.
should be applied?
Okay, introduces
12
a
volt, 5
complication
volt, 3
not
volt.
present with
அதை
separate
decide பண்றது
acknowledgement.
physically.
How long should the data link layer wait longer than the sender's time
For that,
period?
Okay,
Okay,
7
so
layer.
this data link layer it uses this one piggybacking method. The frame will be retransmitted, defeating the whole purpose of having acknowledgement.
But
Of
OSI
course,
layer is
the
complete.
data
Next,
link layer
TCP/IP
cannot
layer.
foretell the futures.
So after
so it
10
must
minutes break,
restart
we continue.
resort to
Okay.
same ad hoc scene, such as waiting a fixed number of
Yes, sir.
milliseconds.
Okay, sir.
If a new packet arrives quickly, the acknowledgement is piggybacked onto it.
Sir, I sent my mail. Sir.
Otherwise, if no new packet has arrived by end of this time period, the data link layer just send a separate acknowledgement frames. If there is no data frame, that data link layer it send a acknowledgement frame separately. Okay, this is called piggybacking. Next, sliding window protocol. So what is mean by sliding window protocol? In all sliding window protocol, each outbound frame contains a sequence number. But every outgoing frame it has sequence number. Okay, from 0 to some maximum, 0 to 99, 0 to 49, like that. The maximum is usually 2 power n minus 1. So n is that is 100. N is 100 means 2 power 100 minus 1. Okay, so maximum is 2 power n minus 1. So the sequence number fits nicely in an n bit field. The stop and wait sliding window protocol uses n is equal to 1, restricting the sequence number to 0 and 1s. So more sophisticated version can use arbitrary n's. Here in sliding window protocol, so there is one stop and wait protocol. So it will sending a data, that is it will stop, okay, and wait. So after receiving the signal, after receiving acknowledgement signal, it will send another data frame. That is called a stop and wait protocols. So the essence of all sliding window protocol is that at any instant of time, the sender maintains a set of sequence number corresponding to frame it is permitted to send. These frames are set to fall within sliding window. Similarly, the receiver also maintains a receiver window corresponding to the set of frames it is permitted to accept. The sender's window and receiver window need not have the same lower and upper limit. The sender window and receiver window need not have lower and upper limit, even have the same size. In some protocol, they are fixed in size, but in other, they can grow or shrink as frames are sent and received. So here, when we send a data frame to receivers, it has no upper and receiver upper limit and lower limit. So if they wish, it can send any number of data. So they are fixed in size. Each packet or each data frame 10 bytes or 10 kilobytes. Okay, so in the same fixed number of packet, it will send to the receivers. The sequence number with in the sender's window represent frames sent but as yet not acknowledged. The sequence numbers within the sender's window represent frames sent but as yet not acknowledged. Whenever a new packet arrives from the network layer, it is given the next highest sequence number and the upper edge of the window is advanced by 1. When an acknowledgement comes in, the lower edge is advanced by 1 step. So the sequence number with the sender's window represent frame sent but as yet not acknowledged. For a sequence number 1, there is a data frame. It is a sequence number 1. It's sent to the receiver, but it is not acknowledged. So whenever a new packet arrives from the network layer, it is given the next highest sequence number and upper edge of the window is advanced by 1. So when an acknowledgement comes in, the lower edge is advanced by the ones, advanced by 1. So for example, so data frame 10 is sent. Okay, so once data frame is sent to 1, next data frame 9 it should be received. Then data frame 8 should be received. Then a data frame 7 it should be received. Like that, it will send to the sender to receivers. So that is a sender and receivers. This is sender, that is receiver. It starts from 0 to 1, receiver. Okay, here also same that 0 to 1. Here 1, then 1 to 2. Okay, then 1 2 3, like that. Every time it send one data frames. Okay, after 10 minutes we meet, we can start, we continue the network classes. You take 10 minutes break. Okay, hello students, we take break.
Okay, sir. Okay, sir.
Okay, sir.
Okay, sir. Okay, sir. Green, green, blue.
Okay, shall I continue? Shall we discuss? Hello. பார்க்கலாமா? ஓகேவா? ஹேண்ட் ரைஸ் பண்றாரு ஒருத்தர், என்ன விஷயம்? பார்க்கலாமா? ஸ்டார்ட் பண்ணலாமா?
ஸ்டார்ட் பண்ணிடலாம் சார் நம்ம.
ஓகே. இப்போ இது வரைக்கும் நம்ம பார்த்தது டெஃபினிஷன், கம்ப்யூட்டர் நெட்வொர்க் டெஃபினிஷன் பார்த்தோம். நெக்ஸ்ட் வந்து டைப்ஸ் ஆஃப் நெட்வொர்க், அது நம்ம பார்த்தோம். அதுக்கடுத்து டோபாலஜி ஆஃப் நெட்வொர்க், நெட்வொர்க் டோபாலஜி, ஸ்டார் டோபாலஜி, பஸ் டோபாலஜி, ட்ரீ டோபாலஜி, ரிங் டோபாலஜி பார்த்தோம். அடுத்து கனெக்ஷன் மெத்தட், broadband, proprietary systems, interoperability systems, connection method பார்த்தோம். நெக்ஸ்ட் OSI layers, இதை டிஸ்கஸ் பண்ணோம். நெக்ஸ்ட் TCP/IP layers. Okay. TCP/IP layer. The Internet Protocol suite, commonly known as TCP/IP, is the set of communications protocols used for the Internet and other similar networks. If we want to send a data over Internet, so that data it passes through TCP/IP protocols, that is Internet protocols. Okay, so it has two parts. TCP is one part, IP is one part. Internet protocol, transmission control protocols. It has two parts. Generally, we say Internet protocol. Internet protocol means
Okay, shall I
that is
continue?
TCP/IP. Is a set of communication protocols. Okay, if we want to
Yes, sir.
send
Yes, sir.
over data.
Okay.
If we want to send a data over Internet, our data it uses TCP/IP protocols. So what the protocol it does, okay? So it's the protocol it send data from one computer to another computers. Okay, yeah, that is computer at both end. It has different format, it has different coding system, and also it has different data representations. Okay, so it accept one format and converted into another the recipient system format. For that purpose we need protocols. Okay, so protocol means it commonly it is a set of rules and convention. What is mean by protocol? It is a rule, a set of rules and guidelines. Okay, so when data is transmitted, so it should follow
Medium
that
access
rules and
control
guidelines.
sublayer.
That is called protocols. Rules, a set of rules and regulations. Every data transmission, it should follow that rules. There are two parts, two kind of protocols. In TCP/IP protocol, two parts. One is transmission control protocol.
Networks
Another
can
one is
be
internet
categorized
protocol.
in two ways,
Where the first two
point-to-point
networking
and
protocol
broadcast
defined
channel.
in this
So
standard.
point-to-point network and broadcast network, already you know. Point-to-point network, one system directly send a data to another system through single
Next.
cables.
So this is
Between
OSI
two
layers.
pair of system, there is a cable. Through cable, data will be transmitted point to point. Broadcast channel means that in multiple systems, it will be connected through single cable. Multiple systems
These are the
connected
layers
through
of OSI,
single
physical,
cables.
data link,
If
network,
one
transport,
station
session,
sending a
presentation,
data,
applications.
all
So
other
these
systems
are the
receive a
OSI of
data. That is broadcasting.
TCP/IPs.
In broadcast network, the key issue
Application,
is how to share
application
the
layer,
channel among several users.
so the application,
More
presentation,
than
session
one
layer,
user
these
want to
job of
occupy
three
the
layers
channel or
is done by
cables.
application
How
layer.
to share? That
Transport
is a
layer is
key
available.
issue in
Transport
the
layer is
broadcast
available.
channel.
Here network layer, here
Example,
inter-network layer.
a conference
job
call
of
with
physical
5
and data link
people.
layer
Broadcast
is done
channels
by
are also
link
called
and
as
physical layers. Here also
multi-access
physical
channel
layer is
or
available.
random access
Application,
channel. Okay,
transport,
so the broadcast
inter-network,
channel is called
and also
random access
link
or
and physical.
multi-access
There is
channel.
two parts.
Multi-access
Data link
channel
layer,
belong to
data
a
link, it is called
sub-layer
link.
at the data link
Physical
layer
layer
called
is
MAC
called.
sub-layer.
Okay, so these are the
Multi-access
5 layers in
channel
TCP/IP.
belong to a
7
sub-layer
layers in
that in data link layer, which is
OSI
called
layers.
MAC,
Job of
medium
medium
access
layers
sublayer.
done by application layer
Medium
in TCP/IP.
access controller
Okay,
sublayers.
job of data link layer
So the
physical
channel
layer is done
allocation
by
problems.
link and physical
So
layers.
MAC sublayer,
So these are the
it resolves the
number of layers
channel
in
allocation
OSI and
problem.
TCP/IP.
Static channel allocation in local area network and
Next,
metropolitan
function,
area network.
application
Dynamic
services,
channel
applications,
allocation.
functions of
Pure
application layer.
aloha and slotted
Email,
aloha.
SMTP, simple
and
mail transfer
CSMA.
protocol.
Network
These are the channel allocation
SNMP, FDM,
www,
and
HTTP,
drawback
and other
channel
services.
is wasted.
Email,
One or
network
more station
management,
do not send
www,
data.
and
In
other
static
services.
channel
Transport,
allocation,
end-to-end
channel
message
allocation is
integrity,
wasted.
UDP,
If one or more
TCP.
station want to transmit data.
So here transport
if
layer
users
will
increases,
take care
this
of
will not support it. The number of users
delivery of
is
single
increased.
packet in OSI
Static
layer.
channel, it will
In
not be
TCP/IP
supported.
layer, so
There
there
is
are
a drawback.
two parts.
Next,
UDP
dynamic
and TCP.
channel allocation.
TCP it take care. It
Pure
is a reliable
aloha
data
and
transmission.
slotted
TCP,
aloha.
data transport control protocol. UDP, user datagram protocol. So it is
Pure
unreliable
aloha
data
and
transmission.
slotted
For
aloha.
wireless transmission, UDP protocol is required.
CSMA
For wireless, UDP protocol is
CSMA
required.
collision
For
reduction.
wireless
CSMA collision
transmission,
access.
TCP
There
is
a
required.
two method in CSMA.
And data error
that
recovery.
is two way
TCP
of
is also
dynamic
solved
channel
by
allocations.
error recovery. Internet protocols, connectionless,
Yes,
best
pure
effort,
aloha
packet
method.
delivery.
In 1970s,
IP means
Norman
internet protocols.
Send
It send a
and
data
his
from
colleagues
one node to
devised
another
this
node.
method.
Internet.
Normal
Network
Abraham
interface.
devised this
Almost
method
any
used
network
ground-based radio
So in network interface means
broadcasting.
there is physical
Used
and data
ground-based
link layer.
radio
Transfer
broadcasting. This is called the Aloha system. The basic idea,
Another
many
computers.
users are competing for the use of single shared channel. There are two versions of Aloha, pure and slotted.
So there is a
There are
function,
two
another one.
Aloha protocol, pure Aloha and slotted Aloha. What is Aloha system?
TCP/IP architectural model.
Using of
Application layer, it
ground-based
supports
radio
FTP,
broadcasting
SMTP,
to
Telnet,
send
DNS,
a channel
SNFP,
to transmit
RIP.
a channel.
These
It
are the
uses
services.
radio
These are
based
the
broadcasting. That is
applications
called
done by
Aloha
application
systems.
layer of
In Aloha
TCP/IP
2
model.
protocol.
And transport
Pure Aloha,
layer,
slotted
transmission
Aloha.
control
Pure
protocol,
Aloha.
TCP, user datagram protocols. Okay, there is a
pure
architectural
Aloha does
models.
not require
Internet layer,
global
IP,
time
internet protocols.
synchronization.
Network
Whereas in
access layer,
slotted
subnet,
Aloha, the
Ethernet,
time is
and
divided
token
into
ring
discrete
fiber,
slot into
FDDI.
which all
So,
frame must fit.
that is,
in
we
pure
need
Aloha,
physical transmission.
no
to transfer
time
one data,
synchronization.
one place to another
As
place.
it is,
The Ethernet is a
transmitting
cable,
data.
and
But
FDDI
in
is a
slotted
token ring
Aloha,
fiber.
each
Through FDDI,
station it
computer
gets
is
time
connected
slot.
from one
When
place to
it
another place,
slot
one
comes
computer to another computer.
It's
These are
transmitting
the
data. So
architectural
let users
models.
transmit whenever they have data to be sent. Okay.
So this application layer of TCP/IP is comparable to the application presentation and session layer of the OSI model, all combined into one.
Sir,
It
audio
provides a
mute
way
ஆயிடுச்சு
for
sir.
applications to have access to network services. This layer also contains the high-level protocols. The main issue with this layer is the ability
So
to use
Aloha
both
system
TCP
means
and
it is
UDP protocols.
ground-based transmitting, ground-based broadcast, radio broadcasting. That is Aloha system. Aloha system, it transmit data using radio broadcasting. It uses two protocol, pure Aloha,
Example,
slotted Aloha.
TFTP uses
pure
UDP
Aloha,
because
will
usually
not
on a LAN,
follow
the
time
physical link or short
synchronization.
enough to
As
ensure
it
quick
has
and
data.
reliable packet
Okay, it can
delivery
transmit
without
the
many errors.
data.
SMTP instead
whenever
of
it
uses
it
GCP
has
because
data,
of the error
it
checking
transmit.
capabilities.
That is pure
Since
Aloha.
we consider
But
our
slotted
email important
Aloha,
information, we would like to ensure a safe
user or
delivery.
station, it has assigned a time frame. When time comes, okay, there's a user
UDP,
sending
user
a
datagram
data.
offering
So
a
not
direct
all
way
the
to
data.
send and receive
Yeah,
datagram
whenever they
over
have
an
data,
IP
it cannot
network
send.
with very
Okay,
few error
when the
recovery
time
services.
comes, they send a data. That is
Here
sorted
UDP
okay, you can
means
difference.
that is
You
a
can
datagram service.
you know difference between pure
Through
and
it is
sorted aloha.
wireless
Pure
service.
aloha, whenever
Through
they
wireless,
have data, it can
that
send.
user
Sorted
datagram
aloha,
protocol is available.
when time
CFTP,
comes, it's sending a
trivial
data.
file transfer
Okay, to
protocol,
avoid a
simplified
collisions.
version of the
Let
FTP
users
protocol,
transmit
which has
whenever
no
they have data to
security
be sent.
security
There will
features.
be collision and collided frames will be damaged. So if the data is collided, the collided frame, it will be damaged. Senders will know through feedback property whether the frame is destroyed or not by listening a
Data
channels.
in TCP.
Before sending a
Host.
data, sender
Host means
know,
our laptop.
okay, the
Target
channels,
web server.
okay, it
HTTP,
observe,
through
listen the channel,
HTTP,
whether
data
the
is
channel
passed
is free
and
or
transport
busy.
layer,
With a
application
LAN,
layer is done on
it is
HTTP
immediate.
protocol,
With a
transport layer
satellite,
is
it
done
will
on
take
TCP
270
protocol, network layer, internet protocol.
270 meter
So
per
each
second.
layer,
If the frame was destroyed,
require
the
one
sender
protocol.
wait
Data link layers. Okay, from the data link layer, it transfers
random
to
amount
the
of time
media
and
for
again
data
sends
transfer.
the
That is
frame.
Ethernet.
If the
There is a
frame
cable.
was destroyed,
From the
the
Ethernet
sender
cable,
waits
it put to data
random
link layer,
amount of
then
time
network
and
layer,
again
transport
it
layer,
sends.
application
Okay,
layers.
the waiting time must be random, otherwise the frame will collide over and over. So here user A, B, C, D. In user
Another
A,
thing,
there is
transport layer.
user A sending a
This
data
layer
frame.
acts as
User
the
B
delivery
sending a data
service
frame.
used
C
by the
sending a frame.
application
D
layer.
sending a frame.
Again, the two protocols used are TCP and
So
UDP.
once
The choice is made based
before
on the
reaching
application
a
transmission
station,
reliability
the B is sending
requirements.
another
The
data.
transport layer
Before
also
reaching
handles
another,
all
C is sending
error
a data.
detection
And D is
recovery.
also sending a
Transport layer also handles error detection. It detects the error as well as it corrects the errors. That is the
frames
job
are
of
transmitted at completely
transport
arbitrary
layers.
times.
It has
Okay,
two
at
protocols,
different at
TCP
discrete
and
intervals,
UDP.
frames are
TCP is a
at
reliable
discrete intervals,
communication
frames are
protocol,
sent.
communication
Whenever
service.
two frames
UDP is
try
the
to occupy
unreliable
the channel
service.
at the same time,
Connection protocol.
there will be a
Connection.
collision and both will be
Connection.
destroyed. When
Unreliable
two stations
connection.
is sending a data frame in the same single channel, both are collided, okay, and destroyed. We have to
It
find
uses
out what is the
checksum,
efficiency of
acknowledgement,
Aloha's
and
channel.
timeouts
Let us
to
consider
control
an
transmission and
infinite collection
end-to-end
of
verification. That
interactive
is
users
transport layer.
sitting at their
Transport
system.
layer uses
A user
checksums,
will always in
acknowledgement,
two
and
states,
timeout
typing
to
or
control
waiting.
transmissions
In a system,
and end-to-end
user have
verification.
two states,
Unlike the
typing
OSI
state
model,
or waiting state. Let
treats
the frame time
reliability as
denotes
a
the time
end-to-end
required to transmit one
problem.
fixed length frame.
So
Assume that
in
infinite
OSI,
population of users
so
are generating a
there are
new
some
frame according to the
unreliable. In some case, that is unreliable
position
because
distribution with
between two
mean
open
n frame
entity,
per
data
time.
will be
If
transmitted.
n greater
In
than
TCP
1,
IP, it
number of
treats
users greater than
reliability
one
as
user
an
or
end-to-end
generating frame
problem.
at higher data
Between
rate
two
than channel
between
can
two
handle.
entity,
Okay,
data is
so
sent
if n greater than 1 means
secure. So that is
users
a reliable compared to
or
OSI.
generating frame
TCP
at
IP
higher
is a
rate
most
than
reliable
channel can handle.
protocols.
Okay, for reasonable throughput 0
Next,
less than
internet
n less than 1.
layer.
Number of users
So this
between
layer
0 and 1.
is also
In addition to
known as
new frame,
internet
the
layers.
station also
So the main
generate
purpose of this
retransmission
layer
of frames,
is to
old
organize
and
or
new
handle
frame, or
the movement
G
of data
per
on
frame
network.
time.
This
G
layer
greater
is
than or
also
equal
known
to
as
n.
internet layer. The main
What is
purpose
mean
of
be
this
that
layer
is
is to
old and new
organize
frame
or
or
handle
G
the
per
movement
frame.
of
At
data
low load
on
there will
network.
be few
So if
collisions.
the data it
S
moves
equal
from
to
one
G
place to
is
another place,
approximately
it
to
requires
n.
internet protocol.
Under all
By
loads,
movement
at
of
low
data,
load,
we
G
generally mean
approximately
routing
n.
of data over
Under
network.
all
The main protocol
loads,
used at
the
this layer is
throughput S
IP,
is equal to
while
GP.
ICMP
P S
used
is
by
equal to
popular
G P
ping
naught. P naught
command
is the
and
probability that
IGMP are
frame does
also used
not
at these
suffer a
layers.
collision.
We
A frame will
require
not suffer a collision
ICMP
if no
and
other frame are
IGMP.
sent with one frame time of its sort. So after some interval, every station has some time sending a data frame. If it follows, no frame will be collided. A sending a data. After reaching a frame, B it sending a data.
Next,
After the
network.
B frame sent,
This layer
reach
is also
the
known
C
as
it
network
can send.
interface
So
layer.
in this
This
order,
layer normally
no collision
consists
will
of
happen.
device driver in the OS and network interface
A frame will not
attached to
suffer
the
a
systems.
collision.
In
It will
each
not suffer a collision.
system,
No other
it has
frame was
network
sent with one frame time of its
NIC,
stop.
network interface card. So in this network interface card, the network architecture is done. Both the device driver and network interface card take care of communication detail with the media being used to transfer data
Here,
over the network.
let T
To
be the time
transfer data
required to
from
send
one
a
computer
frame.
to another computer,
T is a time
it mainly
required to send
involves
a frame.
a network
If
interface
any other
card
user
and
has
device
generated a
drivers.
frame between time T0 and T0 plus T, the end of frame will
In most
collide
cases,
with the
this
beginning
media
of the
is in
shaded
the
frame.
form of cables.
Okay? So the
Some of
between
famous protocols that are
frame
used
time
at this layer
T0
include
and
ARP,
T0 plus T.
address
The
resolution
T
protocol, PPP,
frame will send at
point-to-point
T0
protocols.
time. So another
ARP
frame
means
will
address
send
resolution protocol. PPP means point-to-point
T0 plus
protocols.
T. Similarly, any other frame
So that is
between
the
T0
concept
plus
of
T and T0 plus 2T
TCP/IP
will bump into the
layer.
end of the shaded frames. Okay, so the probability K frame are generated during the given frame time is given by Poisson distributions. P or K is equal to GK e power minus G, K factorials. Okay, so the probability of 0 frame is just e power G. In an interval 2 frames time long, the mean number at frame generated is 2G. The probability at no other traffic being initiated during the entire vulnerable period is given by P is equal P not equal to E minus 2G, where we got e power minus 2G by using Pk G power K e power minus G. Using this formula, we can get P naught Poisson distribution e power 2G to sending a data with probability of no collisions. The maximum throughput occurs at G is equal to 0.5 with S power 1 by 2 E is equal to 0.184. So that is the pure aloha method. Here, first frame it send. Okay, that is a first frame, and the next frame T0 plus T, T0 plus 2T collide with the start of this shaded frame, collide with the end of the shaded frame. Okay, so start of the second frame, end of the first frame, both are collided. This is end, this end portion, this is first portion. Okay, the collide with the start of the shaded frame, both are collided. So there is a time taken 2 0 plus T and 2 0 plus 2T. That is graph map throughput versus offered traffic for Aloha system.
Next thing, there are two types of technology in
For
network:
pure Aloha,
point to point
S is equal
and
to
multi
G
point.
e power minus
What is
G.
mean by point to
Okay,
point?
so that is S throughput per frame time 0.18 seconds. G atoms per packet time. This is x-axis atom per packet time, y-axis throughput from frame time packet time 0.5. At 0.5, okay, it will be bend in pure Aloha. In
Point to
slotted
point
Aloha,
means
0.36.
Point
It
to
also
point
it will
connection
be bend.
provides
It
a
also it will
dedicated
be
link
bend.
between
That
two
is
devices.
comparison between
The entire
pure and
capacity
slotted
of the
Aloha.
link is reserved for transmission between those two
Next,
devices.
slotted aloha.
There is
So far we
station
discussed
A,
pure aloha. Now
station
we
B.
discuss slotted
Where,
aloha. In
between two
1972,
stations, there is a one
Roberts
communication
devised a
link
method.
or
Device
cables.
means
So
find
station
out.
A sending a
Devised
data
a method
directly
for
to
dubbing the capacity
B,
of
station
aloha
B.
distance.
So no in
this
between
system,
two systems,
the time
no
is
other
divided into
systems.
discrete
Station
intervals.
A directly
The time
sent
is
to station
divided
B. There is
into
point
discrete
to point
intervals with
communications
each
and
of the
multi-point. Yeah, multi-point
in each interval
connection is
corresponding
one
to
in
one
which
frames.
more
One way to
than
achieve
two
synchronization
specific
would be to
devices
have to one
share a
special
single
station
link.
emit a
Okay,
pip
the
at the
single
start of each
communication
interval
link
with a
is
clock.
shared by multiple stations. In a multi-point
In Robert
environment,
method,
the
which has
capacity
come
of
to
the
know
channel
that
is
as
shared
slotted aloha in
either
contrast to
spatially
Abraham's plot
or
aloha, pure
temporarily.
aloha,
So
a computer is not
channel
permitted to
it
send
will
whenever
be
a carriage return is typed.
shared by
Computer is not
multiple
permitted
system or devices.
to send
If several
whenever a
devices
carriage
can
returns
use
is
the
typed.
link
Instead, it
simultaneously,
is required
if several
to wait for the
devices
beginning of
can
the next
use the
slot.
link
So
simultaneously,
when we
it
send
is
one load of
spatially
lot,
shared connection.
okay,
If user must take turns, it is a time shared
after
connection.
unloading, it should reach the
some connection
starting
it
place.
may be time
Again,
shared.
it has to load
Within
and
particular
reach
time
the
period
receiving
link
end.
it should be
So
available
this method
to
is
the
not
particular
obviously
users.
for
Okay, and
pure aloha.
spatially
Slotted
means
aloha only it will
several
take
devices
time.
can
Instead,
use the
it
link
is required
simultaneously.
to wait for
More
beginning
than
of the
one
next slot.
devices
Thus,
can
the continuous
use
pure
the
aloha is
same
turned
channel.
into a
That is
discrete one.
spatially
Since the
shared
vulnerable
channel.
period is now halved, there are no other traffic during the same
Direction
slot
of data
as
flow.
our test
So that
plane
is
is e power minus g, which leads
mainframe.
to
This is one direction.
s is equal to
Communication
g power
between two
g into
devices
e
can
power
be
minus
simplex,
g. At
half
g is equal
duplex,
to 1,
full
slotted
duplex.
aloha will have maximum
This is
throughput.
the one
So
direction
s is
only.
equal to 1,
Mainframe monitor.
1 by e or
Simplex.
about
B,
0.356.
half duplex.
Twice of
Station
pure
A,
aloha.
it's sending a data to station B. Okay. So the station A, it's sending a data to station B. After receiving data, station B, it's sending a data to station A. So at a
So
time,
now we
any
discuss
one
the
device it
slotted
communicate
aloha.
to other
First
system.
pure aloha we
Okay,
discussed.
not
Now slotted
simultaneously,
aloha.
but
In
full
slotted
duplex.
aloha, so
Okay, so it has two cables. In full duplex, here there is one cable that is wrong. There
per
are two
second
cables.
gs is equal to g
One,
into
when
e
one
power
station
minus g.
communicating to another one, at the same time, there's another one communicate to first one. Station A communicate to station B.
Next,
At the same time,
topic,
B also
carrier
communicate
sense
to
multiple
station A.
access
That is full
protocol.
duplex.
Protocol
So there is
in
a
which station
communication
listen
between
for a
two
carrier
devices. Communication
and
method.
act accordingly are called carrier sense protocols. So to send or to receive, we use protocols. Okay, before sending a data, user must watch or listen the computer. Okay, so if channel is free, it transmits a data. If channel is busy, and it wait until the previous one is completed. So that is the carrier sense multiple access protocols. When first one, persistent CSMA protocol. When a station has data to send, when station has a data, it is listen to channel if anyone else transmitting at the moment. If the channel is busy, the station waits until it becomes idle. The channel is busy. Channel means cable. The station waits until
Internet
become
architecture.
So
So the internet architecture evolved out of experience with the
when the
earlier packet switching
station
network
detects an
called
idle channel,
ARPANET.
it
So
transmits
both
a
the
frame.
internet
If,
and
if the
ARPANET were
cable
funded
is
by the
no user
Advanced
occupy the
Research
cable
Project
or
Agency.
transmit a data.
ARPA means
So
it is a US based organization,
Another
okay,
station,
that
they
is
will
funded agency.
detect
The
the channel
internet and
transmit
ARPANET
a frame. If a collision occurs, the
around
station
before the
waits a
OSI
random amount of
architecture,
time and starts
before
the over again. The protocol is
invention of
called
OSI,
one
ARPANET is
persistent.
available.
Also, because
And
the
the
station
experience
transmit with
gained from
probability of
building
1
them
when it
was a
find
major
the
influence
channel
on OSI reference model.
ideals.
Okay,
So if
instead
channel
of
is
having
ideal,
7
it
layers, a
occupy
4-layer
sending a
model is
transmitted
often
data
used
to
in
the receiver.
internet.
If
So there are
channel
4
is
layers used in the internet.
busy, user or station has to wait till the previous one is completed. The propagation delay has an input
So which already we
effect
discussed,
on
that
the
is TCP
performance
IP
of the
layer.
protocol. The longer the propagation delay, the
Next,
worse and the performance
error.
of the protocols. Even
Networks
if the
must be
propagation
able
delay
to
is
transfer
0,
data
there will be
from
collisions.
one device
If
to
two
another
stations
with
listen the
complete
carrier,
accuracy. Okay, so it with accuracy, most accuracy,
if two
the node
stations listen the channel
transfer
that is
data to
ideally the
another
same,
ones.
both
Some
will
part
send
of
frame
message
and there
will
will be a
be
collision.
altered in transit, then that the entire content will arrive intact. So many factors
First one,
like
persistent protocol.
line
In
noise
persistent
can
protocols,
alter
we
or
use
wipe out one or more
if
bits
two
of given
channel
data
listen the
unit.
channel
This is
that
known
is
as
ideally
errors.
same,
So
both will
here
send
errors
frame and
means, so bit
there will be
during
collisions.
transmissions, data bit it can be corrupted, or it may be lost
On
due to
persistent
heat
CSMA,
issues
in
or
this,
technical
before
issues,
sending a
bit
station,
is
sends the
altered or
channel.
corrupted.
Here
So there are
station
two types of errors: single bit error or
listen
burst
the
error.
channel or sends the channel. If no one else is sending, the station begins
Single bit error
doing
it
so
means that
itself. If no
only
one
one
else is
bit of
sending,
given
the
data
station is
unit
sending a
is
data.
changed from 1 to 0 or from 0
However,
to
if
1.
the channel is
Burst
busy,
bit
the
error,
station
it
does not
means that
continually
2
sends
or more
it,
bits
but it waits
in the data
random amount
unit
of
have
time
changed.
and repeat the
So,
process.
so if
This
only one
algorithm
bit
leads
is
to
changed, that
better
is
channel
single bit error.
utilization, but
If 2
longer
or more
delays
bit are changed,
than
that is called
one
a
persistence.
burst error.
So one
So this is a
persistent means
data unit sent
if
by the
no
sender
one is
machine. Here
sending,
0 0 0
it
1 0 1 1
starts
0. These are the bit
data
pattern.
or
Here
frame to
the bit, these are the
communication
bit
lines.
pattern received
If
by receiver
everyone is
machine. Here
in
0
communication
1
line,
0.
it will be
So here
more
change. Here this 1 alter to 0. This 0 alter to 1. Here 1 is 1 same, 0 0 same. Here 0 is altered to
if
1.
no one else
So
is
3
sending, the
bits are
station begin
changed.
doing itself.
Okay, this
If
is
channel
called
is busy, the
burst
station
error.
does not continually
If error
senses,
is
but it waits
detected,
random
first
amount
it
of
should be
time,
detected,
then repeat the
then it
process.
should be
If
corrected.
channel is busy, that station it wait and for the particular time and then repeat the process. This algorithm leads to better channel allocation but longer delays than one persistent calls. Okay, why with persistent CSMA, what happens if two channels become active when the third is busy? Both wait for the action station to finish, then simultaneously launch a packet resulting collision. There are two ways to handle this problem. P persistent CSMA. The first technique is for waiting station not to launch a packet immediately when the channel becomes idle. First lost coin and send packet only if the coin comes up heads. If the coin comes up tails, if coins come up heads, okay, it send you a packet. If coin comes up tails, the station wait for some time, then repeat the process. The idea that if two stations are both waiting for the This reduces the chance of collision from 100% to 25%. So if two stations are both waiting for the medium, so it reduces the chance of collision from 100% to 25%. A simple generalization of the scheme is to use a biased coin, so that the probability of sending a packet when a medium becomes ideal is not 0.5, okay, but p where 0 less than p less than 1. We call such a scheme p persistent CSMA. The original scheme where p is equal to 1, that's called 1 persistent CSMA.
Next
So first we use one
framing.
persistent protocol.
What is mean by
persistent
framing?
protocol?
It is the one of the service link data link layers. The stream of bits are
Non-persistent
not
CMA.
advisable to
Then now we
maintain
use
in network.
P-persistent
A group of bits,
CSMA.
it cannot be
first
maintained in
technique is
network.
for
When an
waiting
error occurs,
station
then
not to
entire stream
launch a
have to
packet
be
immediately.
retransmitted.
When the
So we
channel
send
becomes
10
ideal.
bit of
Okay,
data.
but the toss,
That 10
but
bits
first
in
toss
transmission, in
and
transit,
send a
it
packet.
may be corrupted. Any 2 bits
Only if the
out
coin
of 10,
comes up
any
tails.
2 bits is
So
corrupted.
if the coin comes up
Okay,
tails,
so we cannot
the
continue
station
further.
wait
So we have
for
to
some time.
retransmit
Then
again
repeat the process.
10 bits.
So the idea is that
whenever
if two
error
stations are
happens,
both
we have to
waiting for the medium,
to avoid this, the framing
this
concept
reduces
is
the
used.
chance of
In
collision
this, the
from
stream of bits are
100%
divided
to
into manageable
25%.
bit units
A
called
single
frames. The group of bits,
generalization,
the data link
a
layer,
simple
it receives from
generalization of
network
scheme is
link.
to use
Okay,
a biased
upon
coin,
receiving a
so that
bits,
the
it
probability
makes
of
up several
sending a
data
packet when the medium becomes
to achieve, we are
free
using several ways.
is not
Byte
0.5
oriented,
but p
bit
where 0 less
oriented,
than p less
clock
than 1.
based
We
protocol.
call such a scheme p persistent CSMA.
Byte oriented protocol means
so there are three types:
each
p
frame is
persistent
considered
CMA,
as a collection of
CSMA,
bytes
CD,
rather than a collection
CSMA,
of bits.
CA.
There are two approaches. Each frame is considered as a collection of bytes rather than collection of bits. So each frame it considers a bytes, and there are sentinel approach. Okay, in this approach it uses special characters called sentinel character to indicate where frames started and end. This approach is called character stuffing bit. One special character is stuffed between bits. Between bits, one special character, that is byte. Okay, to identify the start of the frame and the end of the frames. At every end of the frame, the one special character, it will be stuffed at the sending side. At the receiving side, that stuffed character, it will be de-stuffed, that is removed. So the newly inserted by character is removed at the time of receiving. So to identify start and receive end of the bit, we use start of the
far
frame,
we
end of
discussed
the frame,
non-persistent
we
CMA, P
stuffed
persistent
one
CMA,
character.
one persistent
At
CMA.
the receiving side,
So what
it
is
will be
mean by
de-stuffed.
non-persistent
That is
CSMA?
sentinel
If channel
approach.
is busy,
Okay,
the
and
station does
byte
not
count
continually
approach. In this
sends,
approach,
but it
number of
wait
bytes
random amount of time. Repeat
in
the
frame
process.
or
If
counted
no one else is
and
sending,
entered
the station
in the
begins
header.
doing so
The count field specifies how many bytes are contained in the frame body. Example, digital data communication message protocol. So byte count means, okay, we can here every
Next CSMA, CA.
bit it will be counted. If number of bits or more.
What is mean by
Identify
CSMA-CA?
there
In
is
many
some
wireless
error.
LANs,
Whether it is
unlike
more or
wireless
less,
LANs,
we can
either it is
identify
wired or
data
wireless.
bits
The
or
station
current.
has
Okay,
no
if
idea
number of
whether
bits
the
are
packet
equal,
collided with
okay,
another
if
packet.
we send 7
So
bit,
we will
at
not
the
bother
same
about
7 bit is
collision
received by
data.
receiver.
Okay,
So
until it
there is
receive
no
acknowledgement from
need
receiver.
of
In this
alternation.
division,
One bit will be
collisions
accepted.
have
Okay,
a
that is
greater
byte
effect on
count. Here
performance
counting
than
the
with CSMA-CD, where avoid
byte.
collisions.
Here byte
If possible, CSMA-CA is basically persistent
bit
with the
oriented
twist,
protocol.
and then
it views the frames as a collection of bits. The synchronous data link control
where colliding packets
SDLC
can be quickly
protocol
detected and
developed
aborted.
by
So
IBM
once
is
the
an
packet
example
or
of a
frame
bit
is
oriented
collided, it
protocol.
will be
It
detected
was
and
later
it will be
standardized
aborted.
by
So
the
it makes sense
ISO
to try to
higher
avoid
level data
collisions.
link.
If possible, CSMA-CA is persistence
Higher
with the
level
twist
data link
that
controls.
when the medium
So,
becomes idle,
there are
the
two
station
kinds
must
of
wait
bit
for
oriented
time
protocol,
called the infraline
SDLC
spacing
and
or IFS
HDLC.
before contending for a
SDLC
slot.
developed by
A station
IBM.
gets a higher
Okay, so
priority.
it is bit
It
oriented
is
protocol,
allocated
and it is standardized by an ISO as high level data link control protocol HDLC.
It is allocated smaller inter-frame spacing. When a station wants to send transmit data,
So that is a
it first
format
checks
of
the medium is
HDLC.
busy.
It is a bit
If
oriented
it
data
is,
link protocol
if it
designed to
is, it
support both
continuously
half
senses
duplex and
medium,
full duplex
waiting for to become
communication
data.
over point to
When
point
the
and
medium becomes
multi-point
idle, the
frame
station
format.
first wait
Beginning
for
sequence,
interference spacing
header,
corresponding
body,
to formerly
CRC, and ending sequence. The
to
beginning
its
sequence
priority
8
level, then
header
sets
16
contention
bit,
timer to
okay,
a time
at
interval randomly
body and
selected in the
CRC
range.
15, okay, and ending sequence 8 bit. So HDLC
Next,
denotes both beginning and
collision-free
end of a
protocols.
frame.
First one,
It denotes
bitmap protocols.
beginning and end of the frame with the distinguished bit sequence 0, 1, 1, 1, 1, 1, 0 to guarantee that a special sequence does not
So
appear
last one we discussed
inadvertently anywhere else in the
collision
frame. HDLC uses a process called bit
access.
stuffing.
Now we use
So HDLC
collision-free
used for
protocols,
bit
a
stuffing.
bitmap protocols. In the basic bitmap method, each contention period consists of exactly n slot. Each period contains only n slot.
Next,
If station
slot
0
based
has a
protocols.
frame to
The
send, it
synchronous
transmit one
optical
bit during 0
network
slot. Okay,
SONET.
so no other station
SONET
is allowed
means
to transmit
synchronous
during this slot.
optical network
Regardless
is one of the
what
protocol
station 0
using
does,
slots
station
based
1 get the
framing
opportunity
protocol.
to transmit
What is the
a
use of
1
SONET?
bit.
It
Okay,
was
so if
developed by
any
the
one
ANSI for
station
digital
sending a
transmission
data
over
and all other
optical
stations
network.
should wait.
Optical
Okay,
means fiber
according
optical
to this
cable.
time slot,
Okay,
it
for
should
fiber
sending a
in fiber
data.
optical
So that
cables,
is the
we use
bitmap
SONET protocol.
protocols.
It
Here
addresses
you
both
see
framing and encoding problems. A SONET frame has some
0, 1,
special
2, 3,
information
4, 5,
to
6, 7,
distinguish
8
where the
contention
frame
slots.
starts
Okay,
and
at
when. To
3,
identify
at 5,
beginning of the frame
there
and
will
end
be a
of the
1
frame,
bit.
we use
Frames 1 to
SONET
1,
protocols.
3. Okay, and 8 contention slot. User 3 and user 7, it's sending a data.
Next thing,
Okay.
error
So
detection.
among
For
others,
reliable
among 5,
communication
only
errors.
2 stations
For reliable
sending a data.
communications,
The
error
first
must be detected
3
and
it's sending a
corrected.
data. Then 7 it's sending a
So,
data.
during transmissions, error rate
This
is
is one
very
bit
high
protocols.
in wireless
Next, basic
transmission. Error rate
bitmap
is very
protocols.
low
Since
in the
everyone agrees on who goes next,
physical
there will
transmission.
never be any collisions. So among multiple users, they have come to common agreement.
So how error
who goes
it will
next?
be corrected?
Who go now? Okay.
When we sending it
So after the
bit
loss ready
along with
station, has
extra
transmitted
extra bit
its
it will be
frame,
attached,
and even
both
all stations
data
can easily monitor.
bit and
Another
extra
n
bit
bit
will be
contention
sent.
period is
Okay,
weekends.
if any
If
bit
station
is
becomes ready
altered,
just
so
after
we can
its bit
adjust with
slot
the
has
extra
passed,
bit. Okay, that is
by
here
it is out of luck
one way of
and must
error
remain
correction
silent
method.
until
Okay,
every station
so
has had
for
chance
longer
and
distance we
bitmap
use
has
it.
come around
For
against
shorter
it.
distance
So if station
we use
ready,
some other method.
its
One error
bit
detection
slot has
mechanism
passed.
is
If station send
is
is
considered
ready,
every data
bit
unit
was
twice.
passed.
The receiving device then would be able to do bit for bit comparison between the two versions
And
of the
sometime
data.
every station has
at
a
data
chance
unit
and
it will be
transmit a
sent.
data.
At the
This is
time of
basic
data,
bitmap
what
protocols. Next,
it
binary
has,
countdown.
it is stored in the
A problem
buffer.
with the
At the
basic
time of
bitmap
the
protocol
receiving,
is that
the
the
data it will
overhead
be
has
compared
one
with
bit
time
per
of sending.
station.
So,
A
okay,
station
if any
waiting to use
mismatching
the channel
happens, data
now
packet
broadcast
will
its
be
address as
rejected.
binary bit sharing.
But instead of repeating the entire data stream, a shorter group of bits
So in
may
binary
be
countdown
appended
method,
to
so a
the end
user
of each
depends
unit.
on the
This technique is called redundancy because extra bits are
administrator
redundant
or
to the
lab
information.
in charge.
They are
And he
discarded
should
as
depends.
soon as the
So a
accuracy of
station waiting
information
to use
has
a
been
channel,
determined.
new broadcast address as a binary string. If station want to sending a
So
data
we
to more than one
send
person,
one
he
group
need
of bits,
address.
5 bits,
After
8
that,
bits,
he
9
only
bits. At the same time, we
transmit
send
a
another
data.
group of bits,
All
001,
addresses are
000,
assumed to be the same
111,
length.
or
All addresses
101, another
assume
group.
same length.
So both
The bits in
data
each
unit
address
and the extra
position
bit,
from
it will be
these
sent
different
to the
stations are
recipients.
Boolean or
Okay,
together.
so you, if any error is
So
altered
bitmap protocol
by
and
calculating
binary
checksum,
countdowns.
it identify whether data
This is
bit
0,
is
0,
correct
0,
or
1,
not.
0,
By calculating
0,
checksum,
1, 2, 3.
it verified.
Bit time. Okay, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0 result. So you
So there are four
transmit
types
0,
of
1, 2, 3.
redundancy
It
check.
transmit
Vertical
0, 1,
redundancy
0,
check
0.
VRC,
0,
longitudinal
0,
redundancy
0,
check
1.
LRC,
Like this.
cyclic redundancy check CRC, and checksums. VRC, LRC, CRC, checksum. Here we use the vertical redundancy check. It is also known as parity check. In this technique, a redundant bit called
This
a
is thing,
parity bit
Ethernet.
is appended to
So
every
there are
data
two
unit so
types.
that the total number of ones in the
Baseband
unit,
Ethernet,
including the
baseband
parity
for
bit,
digital
becomes
transmitter,
even for
broadband
even parity,
Ethernet for
or
analog
odd for
transmission.
odd parity.
So there is a
For
project IEEE at 802. It has
For
60
verticals,
models are
you see
available.
example,
Out of
the
60
data is
models,
01,
one
01,
module
0110. VRC check. Okay,
it
so
takes.
we count.
So here Ethernet is used in the local area network. Through
We
Ethernet,
count number of ones
all
all
the
are
computers
even.
are connected.
1, 2,
10
3,
base
4.
5,
Number
10
of
base 2.
1 is
10
even.
base T,
So we
10
attach
base 5.
0,
10 base T.
0, 1,
Okay.
0, 1, 0, 1. Okay, 1, 0, 0. Number of ones is even means we attach
Next,
0.
in project
Okay, so that
802.3,
along with
cable
parity
links.
bit,
5
it will be
types
same.
of cabling are commonly used. 10 base 5 cabling called thick Ethernet came first. 10 base
For
5
even
came
parity.
first.
For
It
odd
resembles
parity,
as
the data
yellow
unit is passed through
garden
the odd
house
parity generator.
with markings
It counts
every
the number of one
2.5
is
meter
data
to show
unit.
whether
If even
the
number of
taps
one,
go. Connections
then
to
it's set
it
to
are
1.
generally made
Okay,
using
if
vampire
number
taps,
of one is
in which a
odd,
pin
we
is
set
capsularly
0.
forced
For
halfway
even parity,
into several
we
coaxial
set
cable
0
core.
for number
The
of one is even. For
notation
odd
10
number
base
of, for
5
odd
means
parity,
that
if
it
number of one
operates
is odd,
under
we
an
set
orbits,
0. Here
uses
1, 2, 3,
baseband
4.
signaling and can
Here
support
number of one
segment
is
of up
even.
to
So
500
we set
meter.
1. So that is the
So 10 base
original
5
data
cable
and the
thick
VRC
forks,
check. That
maximum
is
segment
VRC, vertical
500
redundancy
meter,
check.
nodes
Next,
100 nodes,
longitudinal
good for
redundancy check.
backbone.
In this,
10 base
a block
2
of bits is organized in a table.
thick
For example, instead of sending a block of 32 bits, we organize them in a table made of 4 rows and 8 columns. We then calculate the parity bit for each column and create new row of 8
So
bits,
here 10 base 5 means
which are the parity bit for
baseband
whole block.
broadcasting,
So this is the
digital
original
broadcasting,
data.
10 megabit per
1110,
second,
1111,
and
1101,
5
101,
means
001101, So
it
this
supports segment up to
data
500
will be
meter. 5
organized
means
in the row
500
and
meter.
order.
The second cable type was 10 base 2 or
Next
thin
one,
Ethernet.
next you write down.
10 base 5 is thick Ethernet. 10 base 5 is thin
Third one.
Ethernet. In contrast to the
fourth one, right?
gardening
Now you
hose
compare.
like thick Ethernet bends easily. Connections to it made using
number of one
industry
is
standard.
even, we
BNC
add
connectors
0.
to
If number
form
of one is
T-junction
odd,
rather
put
than
1.
using
Number of
vampire
one
tabs.
is odd, one like this. We get another
10 base
8
5
bit.
thick coax,
Okay, we
good for
send
backbone. 10
this
base
ones.
2 thin coax, cheapest system.
This is
10
here.
base T twisted pair. 10 base
Longitudinal
A fiber
redundancy
optics.
check. And next, cyclic redundancy check.
Next.
First, we see vertical redundancy check.
10.2 3 max sublayer protocol. Previous one 10.2.2, now 10.2.3 preamble.
Third one, cyclic redundancy check. CRC is based on binary division. Now we do binary calculations. In this
This is
sequence of
Manchester
redundant bits
encoding and differential Manchester
called
encoding.
CRC.
Bit stream
Reminder is appended to the end of the
1001.
data unit.
For this one,
so that
there
the
is
resulting data unit becomes
at
exactly
Manchester
divisible by a
encodings.
second
Okay, one means
predetermined
that is
binary
M,
number
low
at its
to
destination.
high.
The incoming
Zero,
data unit
that is M,
divided by the same number.
0 to
At this step,
low to
there is
high.
no
0 low
remainder.
to high.
The data unit
High,
is assumed to
1.
be intact and therefore accepted. A reminder indicates that the data
here
unit
low
has
to
been
high.
changed in
Low
transit
to high.
and transport must be rejected.
Low to high.
Here,
So
we
1
see
to
one
high
example.
means it will be set
Data
Manchester.
CRC.
Differential Manchester
Beginning
coding.
in CRC
Transition
beginning
here
000.
indicates at 0.
Divisor.
Transition
Data
at
unit
0.
divisor
Lacks of
remainder.
attention
If
here
we
indicates
get 0 accepted, non-zero
leg
means
of
rejected.
transition
Data CRC.
here indicates at
Okay,
1.
0
There is
0
a comparison
n bits
table
divisor
between
n plus 1
bit stream
CRC
1
n bits.
Corresponding signal and 0, that is 0 0. Okay. Another one, the 802.3 max sublayer protocols. Preamble. Each frame start with a preambles.
So that is an example for received data.
Each frame start with a preamble of 7 bytes, each containing
Divisor.
a bit pattern 10101010. Start of frame byte. It denotes the start of the frame itself. It contains
We take binary
10101011.
Okay,
Preamble.
and we can subtract.
Bit pattern 10101010. Start
By
of
applying
frame
this
byte
division,
1010
we get
and last one
001.
destination address.
Okay,
This
so that
gives
is
the
a-
destination address. The
it will
higher
be
order
rejected.
bit is 0
Okay, again
for
we
ordinary
do
address.
binary division.
And
1101 100100
bit 1 for group address.
data plus
multicasting.
CRC.
All bits are
1101.
ones in the destination
Again
field
we do
frame
binary division.
will be delivered
So finally,
to all stations.
it
The
get
46th
000.
bit is used
So data
to distinguish
packet
local
will be correct.
from global addresses.
Corrected. It will be accepted. And this is the cyclic redundancy check by applying binary divisions.
Length field. First one preamble preamble 7 bytes, start of frame by 1010, destination address, a higher order bit is 0 for ordinary address and 1 for group address.
To data field of any
contains
length
the
and
actual
uses
data
the
that the frame
relationship
contains.
between data and
Okay,
redundancy
valid
bits.
frame must
Position
have
of
64
redundancy
bytes
bits
long
in
from
handle code
destination to checksum.
except
If the
checking
frame size is
function
less than 64 bytes, pad field is used to fill out the
reject.
frame to the minimum size.
So input, we calculate a function.
Checksum. It is used to find out the
Rejected.
receiver frame is correct or not.
Data.
CRC will be used here.
Generating function, redundancy check. Here original data is a redundant
Other
bit.
Ethernet
we can
network,
use it.
switch
We can apply
Ethernet
it.
network, fast Ethernet network, gigabit Ethernet network. Switched Ethernet, that is 10 base T Ethernet, is a shared media network, and the entire media is involved in each transmission. The hub used in this network is a passive device. In switched Ethernet, the hub in this network is a passive device. So in switched Ethernet, hub is replaced with a switch. So in switched Ethernet, the hub is replaced with switch, which is active device intelligent, fast Ethernet. So there is a different kind of Ethernet: switch Ethernet, fast Ethernet, and gigabit Ethernet. To transmit data at highest frequency, to transmit data from one system to another system at highest speed. This is 100 base X. Okay, there is digital transmissions, 100 megabit per second, and 100 base underscore TX, two pairs of UTP or STP, and two optical FX optical fibers, and the 100 base 100 megabit per second T4, four pair of UTP. So that is fast Ethernet. So this is 100 base X, TX, 100 base X compared to splitted into two 1 TX and FX, UTP, STP, optical, and 100 base T4, four pair of UTP. This is fast Ethernet and gigabit Ethernet. 100 base SX, optical fiber, multi-mode, 100 base LX, multi or single mode. 1000 base CX STP, 1000 base T UTP. .2.3 frames do not have priorities, making them unsuited for real-time system, in which important frames should not be held up waiting for unimportant frames. A simple system with a known worst case is a ring in which the station take turns sending frame. If there are n stations and it takes t seconds to send a frame, no frame will ever have to wait more than n t seconds to be sent. Broadband coaxial cable, okay, logical ring. Coaxial cable, these are the system 17, 14, 20, 7, 11, 13. Okay, so there is a logical ring. In logical ring pattern, so it is organized. So there is IEEE 802.4 is a token bus. 802.3 frames do not have priorities, making them unsuited for real-time system in which important frames should not be held up waiting for unimportant frame. So 802.3 it will not be suited for real-time systems. So a very simple system with a known worst case is a ring in which the station take turns sending frame. If there are n station and it takes t second to send a frame, no frame will ever have to wait more than n t seconds to be sent. Okay, so here number is a seconds, 17, 14, 20, 7. So with that second period, it send a data. Okay, otherwise,
Chat box
the
ல
next
போட்டீங்களா?
one it will sending a data. The standard 802.4
எஸ் சார், நான் மென்ஷன் பண்ணிருக்கேன் சார் என்னோட
is
மெயில்.
described as a
Sir,
token bus.
B3 batch நான்
Physically,
போட்டிருக்கேன்
a
சார். உமா
token bus
பூஜான்னு
is a
போட்டிருக்கேன்.
linear or
B3 batch full
tree-shaped
அனுப்பிடுவேன் சார்.
cable onto which the
820
station are
batch.
attached.
Wait.
Logically, the stations are
Yavana
organized
Prabha.
into a ring. Logically, the stations
sir,
are
I'm here.
organized into a ring, with each station knowing the address of the station to its left and right.
Asmin.
When the logical ring is initialized, the highest numbered station
Anansi.
is sent the first frame. After it is done, it passes permission to
Yes,
the
sir.
immediate neighbor by sending a neighbor a special control frame called tokens. Here highest framed number 20. This system is sending a data. Okay. After sending a data, next highest frame number token number 17. It's sending a data. So in token ring topology, each station begin a transmission by capturing a tokens. After capturing a token, it begin transmissions. Okay, so once it's sending a data, it receive all other station on the path. So whichever address is matched, only those system or
And உமா
station
பூஜாவை
it will
எடுத்துக்கோங்க
receive a
சார்.
data. Other system it will reject a data or frames.
இதுக்கு
So
மேல
that is
போச்சுல்ல
a
உமா பூஜா
token ring
2002.
method. The token propagates around the logical ring. It will be circulated on the path of the ring, with only the token holder being permitted to transmit frame, since only one station at a time holds a token. Collisions do not occur. Since the cable is inherently a broadcast medium, each station receives each frame. Each station receives each frame, discarding those not addressed to it. When a station passes the token, it sends a token frame specifically addressed to its logical neighbor in the ring, irrespective of where that station is physically located on the cable. It is also worth noting that when stations are first powered on, they will not be in the ring. So MAC protocol has provision for adding station to and deleting station from the ring. So at any time we can add a system into a ring topology, or we can remove a system from the ring topologies. So for the physical layer, the token bus uses 75 ohm broadcast coaxial cable used for cable television. Both single and dual cable system are allowed with or without head ends. Here frame control, start delimiter, preamble. That is a format. Destination address, source address, data, checksum, end delimiter.
Thank you, sir. Received, sir.
Yes, sir, we have received.
Notes received, sir.
சொன்னா கேட்கக்கூடிய அதுக்கு அந்த மாதிரி ஆளு இருந்தா நமக்கு வேணா சொல்லலாமாப்ல அப்படின்னாரு.
சார் சாரி டு இன்டரப்ட். அட்டெண்டன்ஸ் எப்படி சார் சார்ட்ல போடணுமா இல்ல?
லாஸ்ட் கிளாஸ்ல நான் கொடுக்குறேன், லிங்க் கொடுக்குறேன்.
ஓகே சார், தேங்க்யூ சார்.
So next, network use distributed processing in which a task is divided among multiple computers. So advantage of distributed processing: security, encapsulation, distributed databases, faster problem solving, security through redundancy, collaborative processing. So these are the different categories of work which will be splitted or distributed among multiple systems. In a network multiple system, it will take one security, distributed, faster solving, security, and collaboratives. A single task is divided among multiple computers. That is distributed processing. Network criteria. Performance, reliability, security. What is performance? The performance can be measured in many ways and depends on number of factors. So network performance is defined by, measured by different factors: number of users, type of transmission medium, hardware, software. So number of user is limited. At network speed, it will be increased. Type of transmission: fiber optic cable, coaxial cable is reliable ones. Hardware, highly configured machines. Software, software is installed, network software, okay, and OS. So it should be used in the each systems. We can do any task in the network machine. Reliability, another second
network criteria. First one performance, second one reliability. How you measure reliability? This is measured by the following factors: frequency of failure, recovery time. So if frequency of failure means if oftenly failure the network, so we cannot do any task. Okay, so the failure, it should occur rarely, rare phenomena. If it occurs frequently, there is no use of network. Recovery time of a network after a failure. One
Sir,
system is
Homo
crashed.
Puja these add பண்ணுங்க sir.
Okay,
Cross
or
பண்ணி.
data is not sent. Quickly it should recover. Recover time, it should be shorter. Catastrophe, a natural calamity. So it should not affect from the
திருப்பி
natural
போடவா sir?
calamity. That is catastrophe. Reliability. Security, unauthorized access. Network security issues include protecting data from the following. So network security means protect data. How we can protect unauthorized access? We can prevent unauthorized access. So how we can prevent unauthorized access? By assigning
இப்போ செகண்ட் டைம் அனுப்பிச்சிருக்கேன் பாருங்க. OSI
we
layer
can
TCP/IP
every user he has to
ஸோ இன்னைக்கு கிளாஸுக்கு இன்னைக்கு எடுத்த
ID
கிளாஸுக்கு எல்லாத்தையும் நான்
and
PPT
password.
PDF
So they can access. They should not share. They should not access another's data without permissions. Viruses.
வந்து
So
sir.
virus
Thank you so
program,
much sir.
it should affect their software or data.
Okay, today class is over.
Security.
Next Saturday.
So these are the applications.
Okay, sir.
Accessing remote
All of
databases,
you,
accessing remote program,
disconnect.
value added communication facility, marketing and sales, financial services, manufacturing,
Attendance last class
electronic message, directory services, information services, teleconferencing, cellular telephone, cable televisions. So
Attendance
these are
last
the
class la
network
கொடுத்தேன்.
applications.
Okay, sir. Okay, sir. Okay, sir. Thank you, sir.
Thank you. Please all of you leave.
Okay, tomorrow we continue. Today in chat box you share, few students share mail ID. I will send a today notes to your mail. Few students share your mail ID. I will send today's notes. Yes, Kritika. Okay, it is enough.
All of you leave.
I will send to few of them. Please check it.
Sir, I didn't receive, sir.
You did not receive. Okay. I sent to few of them. Please check it. So, okay. Please leave the class. Tomorrow you come and join. All of you leave. Thank you.
Okay, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Thank you.
Sir.
Please quick, all of you leave.
சார் அட்டெண்டன்ஸ்
நாளைக்கு லிங்க் அனுப்புறேன்.
ஓகே ஓகே